Dead straight. Be on your knees begging my forgiveness.
Already 2 minutes late. People set the alarm to get up early.
What time are you at work, Kieran? Okay. There's a mess in here.
Ah, you're here. Right. I guess my auto detector thing picked up. Okay. Let's switch views. Here we go. I don't know. Right. You're probably sitting there watching my desk for a while. Oh, we rushed off to go and get a coffee. So I'm a bit late. Needed a coffee. So who we got here? Gonzalez, Ian, Andy, Daniel, Evrim, is that? So how's it all going? How long is this thing playing on my desk for? I had the holding card up when I walked out. Maybe because I've got my auto detector thing set up, so it switches to the desk. It must have maybe detected my movement. Must have detected the movement when I left the room. It's probably sitting there for 2 minutes playing on my desk. Oh dear, funny. Right. Hey Helmut, how's it going? PM. That's not too bad there. I know someone commented they're setting an alarm for 2:30 AM to get up to come and watch. One of my supporters. Yeah, only a couple of minutes. Yeah. So I got the holding card up, and then I ran out to go and make coffee. It must have picked me up when I moved. So, I don't know. Somehow. Anyway, Macro Age. So it's been a while since I've done a live stream. I don't know. Is it July tonight? It's been ages. Been a while coming. I haven't even checked my phone this morning to see what feedback I had from me posting about this stream. I haven't done anything. I was laying in bed last night thinking, I think I'll do a live stream. I'll do one because I've got some bits of gear we can work on, and got 2 Datrons here. One is dead, one is not, and I want to have a play with those. I thought it'd be a good thing to do a stream on. I've got no idea what's actually wrong with them yet. I haven't even opened them up. No idea. Go on. Right, shall we? Yeah, coffee is important, that's right. Hey Joe, how's it going? Oh, well, I mentioned you, didn't I? Yeah, so. Cool. 18 people watching already, it's alright. So I've got the new YouTube live studio thing running here, which I haven't used before. Well, before it looked very different. So I don't know how some of this stuff's going to work. It may be a little bit different. I'm looking at this screen which shows a representation of what's going on. In fact, I can probably pop it up and show you, actually. Let's show that top screen. I'll show you what it looks like. Here we go. That's what it looks like to me now. So it looks a bit different. So yeah, that's what I'm looking at right now. I'm just trying to sort of see. Yeah, it just looks different. So I'm just got to get used to this look as well. Also, the chat's down the side now. As before, I used to have a browser window open, so I could then look at the chat in a browser window. So yeah, you know, it's good to catch up with people and have a bit of a chat again. It's been a while. Like I say, it's long time coming, this live stream. So I want to play with a couple of bits of gear. Certainly one of them anyway. I want to basically the two Datrons I got here. So one is dead, one is not. I picked them both up quite cheaply. I got a good price for them. I paid a good price for them. And the one which is dead is the one I want to look at first, because that one sounds like it's more interesting. Having something which is completely dead and potentially got a major fault. We'll look at that one first. Or it could be a simple fault, don't know. As far as how things are going over here, well, as far as the virus goes, it's doing okay. We don't have the same kind of issues that many of the other countries are having, so we've got like, basically total freedom at the moment. So there's got the only cases we're basically getting are in the isolation facilities where the quarantine with people coming into the country. So there's nothing really out there at the moment. There has been. So that side of things are fine. We're just living life as normal right now, which is great. I know a lot of other people don't have that luxury. So yeah, to bring out the Danger Mouse mug, I had to bring that out. It's not a live stream, that Danger Mouse mug. How's the audio sounding? Because I've got the microphone kind of right, I think. It's sitting just over here to the side. I do tend to have it in the middle so it catches the other desk as well, I'm over there, but it's not optimised for this position, so hopefully it sounds okay. You probably hear me putting down the mug quite nicely. Oh no. So, what was I going to say? I've gone. Hi from Reeferland. Yeah. Yes, that's right. Willem. Yeah. Yes, the old reefer cap. I've got a reefer cap shirt on here. Reefer cap shirt. In case you haven't seen it. Should have seen it. I've shown it a couple of videos. This idea came to me when I was at work. I was sitting at work. I was actually working at work. And I was like, oh, that'd be a good shirt. So I sketched down this design on a bit of paper and took a photo of it and made a shirt out of it. Why not? And I'm not the best drawer, so I don't know. I'm not an artist. Audio's good, cool. I'll put the cut down over here. I really wish this chair didn't go clunk and creak. It's a bit annoying. So, let's see. So the other thing I want to do, because of this Datron that has, well, no power, I'm going to get my new thermal camera, which I did a video on the other day, the review, and we'll probably have a play with that as well to see how that actually works in real life with a piece of gear which you're trying to fix. It'll be a first for me as well, but from what I saw, when I was playing around with the camera when I did the review, it looks like it's got really good resolution. I could actually pick up a lot of detail on my hand and stuff like that. So I think it will work absolutely fine for doing electronic stuff, as I said in the review. So it'd be quite good to actually have a play with that as well. And you may use that to try and diagnose what's wrong with the Datron. I know one of the Datrons I fixed before, I think it's the very first one I did, which is that one, sitting right there. That had a power supply fault, a shorted rectifier diode, bridge rectifier, or should I say full bridge rectifier. Everyone knows that one. And that was overloading the transformer, so I'd actually, in the video, if you saw that one, you would have seen the transformer getting hot. And I picked that up at the time, but I didn't pick it up soon enough. Wasn't happy with the fact that it got hot in the first place. So at least with the thermal camera, I got a chance to actually catch these things a lot sooner. I mean, I've got the old thermal camera, which doesn't have the same level of resolution. It's not the same quality, so it doesn't do as good a job. So I'm watching people chatting down here. So if you want to ask me questions, stuff like that, or make comments, chuck them down here in the chat. I'm watching for that coming up, and we can have little discussions and stuff. Hopefully, that's the plan. That's the benefit of having live streams. You get to talk to me, and I get to talk to you directly, answer your questions, stuff like that. So it's quite good. So the other thing I've got over here, I may or may not do it. I don't know. I've got a SSD hard drive over here. It's a 480 gigabyte drive. It's from Max Sales. I've forgotten what the company name is now. I've forgotten. It's gone off the top of my head. But it's just a nice drive. But it got a bit glitchy. It started playing up a little bit, and then one day it just died and actually shorted out my. Well, stopped my computer booting up completely. It killed the power supply. It wouldn't boot at all, even try and boot, unless I took that drive out. So that's quite interesting. So I've got that sitting on my desk over here. I might actually look at that. I'm guessing it's some kind of error on the bus, which it communicates with, so it didn't know what to do, so it kind of locked it up. I don't know. So, let's have a play around with something. Change discs. Should switch camera views automatically, which is what I did before, so it should be working. It's a bit of lighting. Something I was thinking about doing as well, it occurred to me that I could actually hook up my main recording camera into this streaming. So instead of using this webcam sitting here, I could actually potentially hook up my recording camera. So you'll see what my camera would normally see. So if I'm actually recording video at the time, that's what you'll see. Very tempted to do that. Let's just spin this around a bit actually. Try to get more sound from my direction. It does mean I have to sort of split the screen off. I do have a HDMI splitter here, so I can actually split the screen off. So the two Datrons, let's try and find one which is broken. Well, they're both broken, but one which is dead. Let's have a look. So this one here has got all the feet and everything on the bottom of it, and this little slide out car, which I was thrilled about. I actually almost won another Datron the other day. Almost. It was the 1072, I think it was, or 1071. Almost got it. Price went a bit higher than I wanted, so I left it, unfortunately. Let's see if I can get some stuff over here. I've got too many meters on my desk. Alright, we shall plug this in here. Can you see this? No, you can't see that, it's too far out of the shot. Hold on. You'll probably want to see the hobby meter. So just breaking the thing off the stand. Here you go. Right, so I've got a hobby meter over here. So you may or may not be able to read what that says. I've got it running through this. Now this isn't converted yet. What voltage is this one on? This is 115 volts, so I better turn this down. Got this somewhere. Okay, so I've got the voltage set up. I'll give myself a little bit more room on this desk. A mess. Need to clean up some more. Like I said, a bit of an impulse decision to come and do this today. Let's fold that out as soon as I've got one. Right. Let's see if it actually powers up. I don't know which one's which. It does power up, okay. But I think this one did have an issue with it. So that's not the one I want to look at. I want to look at the other one. The one which is dead. Actually, so a power draw on that thing, see what it's doing. 22 watts. That sounds fine actually. So this one doesn't seem to have any obvious shorts or anything on the power supply rails, which is good. Let's get the other one out. Because I want to work on a dead one. Hi Peter. Yeah, the ear mug. That's my wife. She got that for me. I don't know where she found it. I don't know where she got it from, but yeah, it's pretty cool. I like it. I have to say it's probably, you know, I don't know which one you would rather get, the DM or the iFixit. Or iFix stuff. Get it right, nice round mug. Right. So this one which is dead. Let's make sure the switch is off. Well, I'm pretty sure it's dead. I did do initial testing, but I didn't look that closely at the time. So look. See what happens. Absolutely nothing. No power draw whatsoever. Okay. Let's put the fuse out. Actually, that's holder's already half out. Is that what it is? That was a screwdriver. No, that fuse is knackered. It's gone. Let's get a new fuse. Actually, this one's this one 15 as well. Yes, it is. That's right. I was thinking of one I was going to buy online. That's a 230 volt one. So what fuse this thing want? This sounds what does it say? Where is it? On it somewhere? I've got to look at the fuse, but sometimes it's easy to read this. 500 milliamp hours, right. Milliamp hours, milliamps. Let's grab one. One of these, hopefully. Just trying to find it. I've got bags of fuses. That's a 100 milliamp. That's not good enough. Come on, where are you? And I've got some. Really wish the writing on this was bigger. I might cheat. Let's look over here. Can I see it now? 0.6. I think this is 0.6, not 1.6. No, it might be 1.6. That's not what I want. 0.6 is close to what I want because I want to convert it to 240 volt as well. Which does. Was it? No, it goes down to 160, doesn't it? Come on. Just want a fuse. Okay, this will do. Maybe. Actually, I've got a kit of fuses somewhere. Oh, that's a very good video. Sorry, guys. I'm just frustrated. This is you, probably. Where are we? Oh, I can see milliamps. 500. There we go. There's a 500. We'll chuck that in. Finally found one. I knew I had one here somewhere. Right. This may or may not be all that's wrong. Doesn't really go in a hole very well. There we go. Yeah, I need to wind that in or something. Why do I never have a screwdriver here? Incredible. Do I have a flat blade screwdriver? Right. I'll keep this because I might blow the fuse out and I have to do it again. Power looks normal. And it's powered up. But we've got no screen. Yeah, we've got a fault for it. Definitely got a fault. But power supply looks normal, so it means it's probably the 185 volt rail which is blowing on this thing. Or the screen is dead. Guess hopefully it's not the screen because that could be a real problem with the display. Right, let's open this thing up. At least I've got something to fix. That's always good. So I buy these things. Want you to chat? Oh, nothing's been said. Come on, guys, talking to chat. I can't have a chat with people, which is unusual for me because I'm not really a chatty person. I'm a waffly person, I suppose. Right. Let's find a screwdriver for these. Got like a hexagonal nut on the side. There we go. I think I'll probably take all the cases off actually. Take all the screws out. I'm probably not even in the shop right now, am I? Yeah, it's always nice to get something that's actually got a fault. Now, I'm just hoping it's not the display itself, because if it's display, then that's a real problem. Involves, well, an awful lot of reverse engineering and work to solve that. I don't know if anyone's ever seen the feedback loop, or feedback loop, I think it is. He does lots of good repair videos as well. He does mostly audio gear these days, but he does do test gear from time to time too. And he's actually done some repairs on these things. This is still sealed, which is good. That's a good sign. This is their own seals they put on before they shipped it. They look a bit older. Simco, calibration void Simco, so it looks potentially good. The seals are intact from the calibration, then it's that's actually a good sign. Anyway, saying it, so feedback loop has actually done a display replacement on one of these things. So he's already done some work on that. So I think he may have had some information on his channel about how to do it as well. He used a whole bunch of all discrete displays. It's basically stacked them side by side because the space is quite limited in that area to try and actually lay something up. So hopefully it's not display. Hoping it's power supply. Power supply is always better. Oh, let's try to get this casing off. Alright, it's top side. Should check the battery too, see what the battery looks like. How good's the view on this? Do I need to zoom this in a bit, you reckon? Need to do something, I think. Let's zoom it in. Although, each time my automatic switcher turns on, it will change the view back to the zoomed out one, won't it? That's annoying. I need to do something about that. I didn't mean to make something. Oh. I suppose you can kind of see. If you can't see, yell out. Let's use this one for the time being. Now I find, although I've got my Siglent multimeter up here, my 6.5 digit, which I do quite like, I do find myself using these handheld meters a lot, mainly because when I'm trying to shoot video, I can get it in the video much easier. If I had the Siglent down the bench, then obviously I'll be using that, but it's up here on the shelf and it's a bit out of shot generally. So that's why you see me using these handheld meters a lot. What's the battery voltage like? 3.7, that does good. That's fine. That's a good start. This is not dead. So, what should we check for? So there's got dual bridge rectifiers over here, and they do, one of those does the display driver as well, so it does the 185 volts where it is for the display for memory. Yeah, I have to refresh my memory on this now. Anyway, so what date we got on this thing? 1987. It's the firmware version. So it's slightly newer than the other ones I've got, or the other ones I've worked on. I'm just trying to have a bit of a look over it and see if I can see anything that's obviously different. The other one I had, there's two versions of this. The later versions have got a different setup over here for the 50 Hz / 60 Hz sensing for the timing system it uses. It actually gets tuned to the line frequency. And one of them's, the later ones have got a crystal in there instead. This one is using a tuned circuit. You have to calibrate that. I'm just looking for anything misplaced. Oh, looks fine. Nothing's unplugged or looks alright. Let's flip it over, check the other side out. I should be recording a video on this, shouldn't I? I should be. Hold on, let's get this fired up. Shows out of practice I'm getting to record video at the same time. Yeah. So I'm going to repeat myself slightly, yeah? Just for the sake of doing the video. If my camera wakes up. What? Right. I will plug the power back into this. So I'll demonstrate it. Switch is off, and it's on. Right. So I'm going to repair this Datron 1062, hopefully. As you can see, I've already started because I'm doing the live stream right now and I forgot to start recording. Yeah, well done. So I've got it running my Variac, or my auto transformer as it actually is. It did have a blown fuse which I've replaced, and it's currently running 115 volts or so, or 113 going in right now, just because it's not been converted to 240 volt yet. I will be doing that at some point. And we turn it on, but we don't have a display, so we need to figure out what's causing this to start with, and that's what I'm working on right now. There we go, caught up. Okay. So I've already had a look around the top here. I can't see anything obvious. It was still sealed. It had the calibration sealed on the side from Simco. I've broken those seals to open it up, so the thing was still sealed, which is a good sign. I mean, it's probably had some kind of electronic failure rather than a physical failure. So I've had a look over the top. Couldn't see anything obvious on here at least. I'll flip it over, check the bottom side as well. But it's probably a power supply failure, most likely. Those bridge rectifiers are terrible for failing. They're known for it. And what do we have in here? We have display driver, resistance board, AC board, and the GPIB board over here. They're still dated 1987, but the GPIB is dated 1986. But it's likely the same firmware, so it's 290070A19 on the GPIB, and it's 290005657 and A's, and then 290113A on the other chip there. So slightly different versions. It's also interesting these ones are stacked. They've got stacks on here. These are offset off the board. Now that wasn't so unnoticed before, but obviously it is. Why is that done? Why have they been stacked? It's like the original sockets are here and it's had another socket pot on top of them. Is it because they're using 2732s instead of 2532s? Doesn't appear to be. They're going straight through. That's curious. I wonder why they've done that. That's interesting. Maybe those sockets were dodgy at some point and someone replaced them and just put some new sockets on top. Maybe that's what they've done. Because these little plug-in sockets do have issues. Sometimes you have to reseat things. Okay. Well, let's have a close look at the bottom, like I was going to do. before I got distracted. See if there's anything untoward on this side. So far it all looks fine. I can't see any plugs which have come loose or anything like that. There's a couple of diodes over here, I'll check those as well before I flip it back over. This one does have the rear input option. So got yeah, rear input, no ratio, no analog, there's an external trigger. And the current board normally go here, and that's what this jumper here is for, so the current board, if you have that installed. Just make sure it's just in the right place. It is. Okay. It basically looks fine. So we need to do some probing around, see what's going on. So you guys can see well enough, can you? Or not? Hey Davis again. Birds, yes, birds. Binode, what does binode op mean? I'm going to have to look that up, see if you're doing something you shouldn't be doing. Just give me a second. No idea. Anyone know what that means? Hi Vladimir, how's it going? Anyway. Right. Let's carry on with this. Can you guys see alright, I'm guessing? No one's complaining about not being able to see. Maybe I'll drop it down slightly or something, I don't know. Don't really need to get the... Oh, maybe I do need to get that in shot still. Just like barely. Come on. Cooperate. Just about in shot, isn't it? Yeah, I think I'm kind of back to where I was, isn't I? Alright. So I'm going to probe around the power supply, check the diodes out first and the bridge rectifiers, because that's likely where the fault is going to be. Can you see that? Barely. You can't get it so both cameras can see it, as is always the trouble when trying to load live streams. Right. So let's check these diodes on this side first, and I'll flip it over and check the bridge rectifiers after that. So I want to see what's going on here. Ah, that showed dead short. That was okay. Right, that's fine then, probably right. Interesting. Get the other way around. Dead short again that way. And that way's looking alright. That's interesting. When we're getting dead shorts in the opposite direction. It's probably the might be the transformer winding that's causing a problem because it's plugged off that. Maybe that's what's causing it. Could be. But in one direction we're looking right. It's not dead short both directions, which would be what I'd expect to see if it was failed. Okay. Flip this over, check the other side out. Trying to pin out for these things now. Okay. That's okay. That probably isn't. That's okay. Got to spin it right. No, I don't. That'd be why. Just do it down the other way. Should be open. Yep. That way. Should be open. Yep. This way should be diode bridge or diode drop. It is. And this way should be diode drop. It is. Same for the other one. Charge up capacitor, that's fine. Likewise there. Charging up cap. Around. I'm actually surprised these aren't blown. It actually makes me a bit more concerned, because I thought it'd be one of these. Right. What else can I check over here? Well, I guess I'm going to check some voltages around. I might put up the circuit diagrams and everything. Bit more work. Right. That's better. The angle's better, is it? It's dropped slightly. You can still kind of see the hopping meter though, can't you? Right, so diodes look fine in the power supply. So I'm going to pull up the service manual for this thing, and we shall have a look at that power supply board in there and figure out what's going on there. Just got to find the manual. I've got it here somewhere. I've got different versions. Which one do I want? One's better than the other one. Hold on. This one here. Let's try and get one to fit on my top monitor so I can show you as well. Hold on a second, try and get this set up. Right, let's change views. So, power supply section is what we're looking at. We've got to find it. So this is for the 1061, 1061A. 1061A is basically the same as this thing. I think the 1062 has different options when you buy it or something like that. It comes with fully optioned or something like that it was. Although I do actually have another manual. Actually no, I'm going to use the other one, because there might be some differences. I've got another one. Let's pull this one up. This is a slightly later one, which is actually what I want. So, because it does cover the 1062 as well. Hi Christian, how's it going? Abelski. Video stalling. Okay. Let me change tabs on the viewing thing. Okay, did show a little bit of stuttering on there. Right. Right, let's find this bloody bit. I know it's right at the end of the manual, but I always forget exactly where. Oh, let's go right to the end. I know it's here somewhere. Let's find it this way. It's the first page of this manual. Well, first page of the diagram section. As I remember it anyway. I could be wrong. Here we go. So is it on there? I thought it was the first page. Oh, it's fan panel, right. So here's the power supply section. So what I've measured is these two bridge rectifiers, W1, W2, just here, and the diodes which were here, D1 and D2. There's no diode in between those, which is a bit hard to get to though. So they looked okay. Now I'm pretty sure W1, I think it was, can't remember, comes W1 or W2. I think one of those did the high voltage supply. So let's have a look at the actual diagram here and try and pin that down. No, W1 does the 5 volt, and it does do that. There we go, minus 175. It is that one that's doing that supply. But Q2 here, so it goes through Q2 to create this minus 175. Oh, great. No, don't do that. So we check all these rails, make sure they look okay. Some of these I know where they are, some of these I've forgotten. So these 15 volt rails are best to check on the analog board. There's a test board, analog board for those. Allows for voltage drop and stuff like that. That's one of the things I fixed on the other Datron, was one of these ones. Was it the negative 15 a fail, I think it was. So I've got 5 volts off this one. These are known for having issues as well with solder joints on these regulators. That's a known issue too, because they used quite a high acid flux solder or something on them, and actually caused the wires. Possible that's related, but it could even be that the display is getting a voltage. It could be the display driver board isn't getting a voltage. It could be some of that. Don't know. I'm not sure which one of these goes where. Because there are two 5 volt supplies. You've got that one here and this one here. Getting stutter? Okay. Right, I'll change the settings on here. I'll reduce my stream settings. I'm surprised my internet's sort of being a bit flaky though. It's likely my end. Okay, I've reduced my stream speed. That might help. I mean, it's only 9:15. My internet should be doing okay now. But when I came in here this morning, I had a bit of a panic because my internet was actually down. I rebooted everything and it came right. So there could be a network issue going on at the same time. I hope not. So let's get a bit closer on this. So that's that minus 175 I'm looking at here for that display. That's what runs the display itself. So I need to check, see if we've got these TP1, TP2. So I should be getting 180 volts between those two test points. And if we are, then that's probably okay. We have to look on something else. Could be the display driver board, possibly. Maybe the display's working, but it's not getting a signal to run. It's possible. Haven't dealt with a display problem on these things before. Yeah, I haven't dealt with a display on these things before. I haven't had any issues with them, so it's a new one on me. No, my computer's pretty quick. It's 3.4 gigahertz, 8-core machine, running nothing but OBS and Google Chrome. So it's, well, and the Acrobat thing. As far as loading goes, it's nothing. I can actually do this. I'm going to pop it up. No, I don't think I can pop it up there, can I? No. My CPU and RAM usage is fine. Yeah, it's not hogging down the machine. Machine's fine. Maybe the rats are eating. Yeah, maybe, I don't know. Yeah, because my internet connection's wireless. So those people that aren't familiar with this, it's been a while since I streamed, so you probably haven't seen it before. But my internet is actually a wireless system, so it's a dedicated point-to-point network. Not very good when it's congested. Shouldn't be congested yet. It doesn't start being congested until usually about 11 o'clock in the morning. So it should be okay, but I don't know. Anyway, so I'll drop the resolution. Well, the bitrate resolution still the same, 720, and that may help. Although I gave a warning 4 minutes ago. That was before I changed it, wasn't it? Yeah, it's saying YouTube's saying the bitrate's 812 kilobit per second. So maybe that's what's happened then. I had that up a couple of times. The other one's 825 kilobit, so I'm trying to stream at 1200. Right now it was 1500, so maybe that'll be a bit better now. I've left that tab open on here so I can hopefully see it anyway. So, fingers crossed. So anyway, let's get back to this thing. Let's carry on fixing this. So I need to measure these voltages at TP1, TP2, wherever the hell they are. Let's find them. Someone's rather nicely marked stuff. Here we go, TP1, TP2 on the corner board up here. So I measure that across those two. If I get 180 volts across those, then the power supply is working. So let's do that. Will it switch? Yes, it switched. Cool, that's still working. So those are over here in that corner. Now, let's put my probe tip things out so I don't short things out. Nice little gift from Pomona, these were. These are one of the review things I got from Pomona. Free set of test leads. These are really nice leads actually. So let's make sure I get onto these okay without slipping off. That looks fine. Power switch is off, is it? Yes. This will be 180 volts DC as well because it's going through the bridge rectifier. So I'm going to test voltages on the supply that goes to the display just to rule out that supply is actually working okay, or prove that the display is working okay. So I need to figure out why the display doesn't work. Because obviously it's either no power to the backlight or the actual display system. I don't know what you bloody call it. A high voltage supply because it's like a VFD display. Or it's the display driver system, which is wrong. So it's not turning the display it's not actually turning the display on. So I can measure over here, and I should be getting 180 volts between these two test points, which is TP1, TP2. Actually, I don't have this turned on. I should turn this on. Got my Nixie clock over here, which you guys can't see on the live stream, but this camera can see it. Give it a second. I don't know why it plays the tune when you turn it on, but it does. That is a gift from a Patreon supporter. I won't name them. They wanted to stay anonymous. Anyway. Right, let's measure these voltages on here. So that has got power going to the unit. I'm going to stick the probes on and then I'm going to turn it on. That way I don't risk slipping with the power on. Show those in there. 180 volts. That's working fine. That rules that out. Okay, this gets a bit more interesting. What's in the filter caps and entrance to the display board? Don't know. Yes, that's the new clock, Joe. You guys can't see it, unfortunately, where it's placed from where the camera is. If I change my camera angle, you might be able to see it, but I don't know. You will see in my other videos I've been publishing. I did it I think it was in a review video. I think it showed up in that for the thermal camera. Okay. So the stream, I gave an error again 3 minutes ago. It gave me another warning saying the bit rate's too low. I'll drop it again. I don't want this to be playing around all the time. If this gets really bad, there is a secondary network I can use, which is in my motorhome. It's also wireless broadband, but that goes through 4G instead, which sometimes can be better, sometimes can be worse. So, right, anyway, let's figure out what's going on here. So we've got no power. So we've got power going to the display itself. So what I should probably do is just check the other power rails first and do all that. Oh, other way. Let's change views. Oh, you don't know what I'm talking about. So I'll check all the power rails first, just to rule those out, because you should always do that. Check power rails. So we know that the very top one up here, which I'll just zoom that off so now you can't see it. We know that those rails are okay because we've got 180 volts across there, so that is fine. That rules out all this stuff. It probably needs recapping. In fact, it's highly likely the whole thing needs recapping. Both the other units I did needed recapping. Power supplies weren't too bad. I think I only had 1 or 2 caps, which is a little bit marginal on the power supplies in the other 2 units. But what I did find is on the analog board, basically every electrolytic capacitor on there was needed doing. But the power supply was a bit more robust. That is quite interesting. So I did them anyway, but just so then I don't have to worry about it. They're done. But they did seem to be okay previously. So this one's probably the same deal. Likely to be mostly okay. I think there was only 1 or 2 caps which I had to worry about really. But we'll check these power supplies out. Make sure all the power supplies are there. So we define TP5 digital common, which is TP4. So check across 4 and 5, and then we've got these 15 volt rails here as well, and that'll be the main supply rails dealt with, and then we can look a bit more closely after that. So between 4 and 5 I should be getting 5 volts, and then I've got these other rails here. PP3 V3 hot. No, I haven't checked that yet. Yeah, I got it, Adam. I got it. Dear. It's in Rossman's channel, you know. I'm fast slower than Rossman. Right. So, TP4 and TP5, let's find those. So there's TP4. TP5 is over here between the regulators. And that is on the bottom of the unit. So we'll try and get to those. So, where are we? There. You can see the back of that one. It's behind these flexes, isn't it? Yes, it is. Of course it is. So, TP4 is right there. TP5 is down there, so I have to get to the back of that one instead. So I have to go on the cables, of course. Still see that? Barely. So I have to go in here like this. Although that's backwards, but yeah, you get the idea. I have to go like that, and that should give me the voltage. Okay. So I'm going to check between TP4 and TP5 for a 5 volt supply. I've figured out where those test points are. So hopefully we'll get something. We'll see. Well, hopefully not. Whichever way. Don't really care which way around it goes. Try and get my probe on there without shorting myself out against things as well. Right. Really nothing there. I'm on the right pans under it. Believe I am. So I'm seeing nothing there. I'm going to double check, make sure I've got the right places. TP5, TP4, yeah, I'm pretty sure I've got that right. This is still complaining about my data rates. YouTube's warning me now. Common anode, common cathode, EFD, I've got no idea. So I've dropped the data rate and it's still not happy. So apparently it's buffering now. Great, buffering. So OBS is warning me as well that it's not handling it. Okay, what I'm going to do, I'm going to go to Motorhome, I'm going to go and turn that system on and jump onto Wi-Fi and use that system instead. And hopefully that'll be better. This is getting worse and worse. So I'm going to go and jump onto that. Okay, so give me a second, I'll be back in a couple of minutes. I'm warning you before I switch over because I might drop the stream out. Right, I'm back. And YouTube's still complaining, OBS is still complaining. Okay. Could give my Motorhome Wi-Fi a chance to boot up and get it all running, then I'll switch over. And hopefully it keeps on going. Someone hide his multimeter. I saw that, Ian. Right. Let's turn Wi-Fi on and see if I can switch over. So I might drop out. If I drop out, come back. Okay. Right. Switched over. I'm now on the Motorhome Wi-Fi. I'm giving it a chance to settle. Even that's struggling. Oh no, there we go. Right, I think we're good again now. No, we're not. Oh, this is terrible. It seems better than the other one. Yeah, OBS is still complaining. So YouTube recommends 2,500 kbs. And I'm not getting that at all. Oh, it's dying. No, this is bad. Nah, this is pretty bad. This is concerning. This stream is really struggling. You think it's right? Well, OBS is saying otherwise. Yeah. Still watchable, you reckon? Okay, well, we'll see how it goes. I'm hoping it comes right. It doesn't normally play up this badly this early in the day. It's usually a bit later on. So I'm on the bus Wi-Fi now, which is going through 4G. Yeah. I don't know. I'm not actually sure it's any better. I'll switch back and let's do a comparison. Yeah, I'm going to switch it back and see what happens. It's about the same. Looks okay there. Well, it's just because it's a static image. It will look better because it's not having to work too hard, but it's still struggling. I don't know. It's very erratic. It's all over the place. Yeah, I need to get this sorted out. Hold on. I'm just trying to. They're bad at each other. So I'll chuck it on the Wi-Fi. And I'll do it on the bus Wi-Fi and run it through the. I'll run it through the 4G and go from there. See how it is. Lead on, okay. Well, I'll leave it on that one. Let's see how we go with that. Yeah, well, we'll try this. Okay. So where was I? Voltages. So I was looking at that TP4, TP5. That's what I was trying to double check, wasn't I? So there's no voltage there. And I want to make sure I've actually definitely got the right places on here. Let's go back up to the top. Go back to this. So I was definitely measuring the right places, and there's no voltage. That may be to do with it. Maybe there's no power supply going to that board, and therefore it won't drive the display. That's my suspicion right now. That could be easy, couldn't it? Yeah, it's hard to sound a small on a still image. Yeah. I'm moving. Yeah. Right. Let's have a look here. So definitely says TP. Oh, is that TP3? Is that a 3, not a 5? Could that be what I'm looking at there? That's 6, 7, 8. There's TP5 over here. There we go, that's what it is. Okay, TP3. I thought it was weird there's 2 points away from each other. So we'll measure these ones again. TP3 and TP4. See, it's not very obvious. Does that look like a 3DU? Looks like a 5 to me, anyway. But then you've got TP5 here, which is obviously a 5. What's that one then? Is that TP3 as well? Or is that 9? That's a 9. That'd be a 9. Yeah, this is the struggle with these things. It's a 3, 5, and 9. I mean, that's a 9. Yeah, look how similar they look. Anyway, so 3 and 4. We'll look at 3 and 4 this time. So actually it's still powered up. So let me now it's been on for a little bit. It's had a bit of warm up time. Just get the thermal camera out and see if anything's hot. I don't want to go and poking things with my fingers on the power supply because you know that can always end up very badly. So let's get the thermal camera out and have a look around, see if we can see anything that's actually wrong with it. Obviously. Feel some warmth over here. There's definitely warmth over here. The only thing is it takes a little while to boot up. But that's a small thing to forgive, isn't it? So we're getting 60 odd degrees over there. 64 degrees. Oh yeah, there's definitely something hot over there. Something which shouldn't be hot. These diodes are 66 degrees. These two here which I measured before. I don't even see it on the camera though. Probably can't see it. I can't see what I'm doing. Is it not switched over? Did it not automatically switch? Oh, hold on. Caught me out. Right, here we go. So, I don't know if you can see the camera or not. With all these lights. With the hotspot. Oh, yeah. Yeah, it's doing a bit of heat in there, but those diodes are surprisingly hot. That might be a clue to what's going on. Right. So I was checking this stuff with the thermal camera, and there's a couple of diodes over here which I checked before with the meter, and they're actually pretty hot, about 66 degrees. So you can see on the back of the board there, if I get the angle right, that area is pretty warm. Check the main boards as well. So it's looking kind of alright. Yeah, I'm seeing some hot spots. You can actually see the warmth in the chips. I'll get it right. Can't see what I'm. Probably can't see what I'm looking at there, but anyway. 54 degrees I'm seeing in this area here. Right there I'm seeing 54 degrees. Yeah, something's hot over here. And I wouldn't expect to see something hot there. 52 degrees I'm seeing. What is it? Might be on the back of the board. Okay, well let's go around here. There's a 50 odd degrees over here. Is it? Oh no, I'm seeing this one still. There's a 50 degrees over here, which is these transistors over here I think. So there's a few little hot spots around the place. It's just showing up quite a lot. But power supply is my concern right now, so I'm 6 degrees there. So I'll shut this back off again. Nothing's going completely off the charts, but there's a few things to investigate, especially over here. And as soon as that's on the display driver board, that's interesting. Right. That's right, I was going to check 3 and 4. That's right. Turn it back on again. Between 3 and 4. Now I've got the right numbering. 5 volts. There we go, 5.1. That's what it's supposed to be. Okay, let's flip this over. and check the 15 volt rails, which I can find over here. So the common was over here somewhere. I think it was that one. There. And this one for 15. Where's the other one? There it is. That's here as well. So both 15 volt rails are there. Okay, so the power supply rails are there, but they've got no display, and we've got the hotspot on the display board. So we'll look there. I suppose those diodes being that hot, I might just check those ones out and see what those are. Stream still complaining. So YouTube, your buffering won't happen if YouTube's getting a bad rate from me but a good rate to you. You won't get buffering. The buffering is at my end. Yeah, 2 frames a second. Yeah. Can't see the multimeter. Oh yes, gone off camera now. Because I've zoomed in. Ah dear. This stream is bad. Let's switch back. So I'll switch back to the other streaming, well, the other networking thing. But yeah, it's not looking good. Thanks for that, Vladimir. That's right. It was because I've got a discount code with Banggood as well. So if you use my discount code, which is on that video, if you look in the description of that video, it's down there, and you can get it to, I think it's for $320 US. I think it was. So it's a good camera. I like it. It certainly beats pants off the one I was using before. Right. So those diodes, find where those diodes are. God, I keep clicking on the wrong bloody windows. Hold on. Zoom out and back out. Zoom this one out. I'll look at those diodes, what are they for? So D1, D2. Where are they? D1, D2. They're running the 5 volt rail. Okay, there's a lot of stuff on the 5 volt rail, so probably fine. Could be a leaky cap. It could be a bad capacitor which is dragging it down, making it work a bit harder, but the voltage is there, so I'm not worried about that. So the main power supply rails are there, and that's the main thing I'll take away from that. Okay. So we need to look at the display board. Let's find that thing. I think I have to take that out and find out why there's a hotspot on that board. I think that's one of the last diagrams in here. That's analog board. That's digital board. I think that's it. Display driver board. Here we go. So I'm seeing a hotspot about here somewhere. Right, R141, was it R41? Sorry, in that area just there is where I'm seeing a hotspot. But I don't think there's anything on the back of the board doing this, so I don't know, maybe there is something going on here. So R41 is the area I'm looking at, or AN2. Let's see what we can find on here. I should check power supplies on this board as well, shouldn't I? There is a TP1 and TP... is it 5? Who knows? TP something. Where are we? Let me know if you see it. It's a bit small. No, it must be on that, but it must be on there somewhere. Okay. There's R39. These ANs are pull something. Not sure which way they're pulling. Where is that resistor? Can I see up to 35, 37? Ah, 41, here we go. That's why it's getting hot. It's going between those supply rails. Okay, so that'd be why that one's warm. That's normal. Right. And there I was poking my finger, there's 180 volts on that thing. That's nice. Glad I didn't find it. Which bit are you looking at, Adam? Diode bridge in one area and separate diodes in another. Yeah, resealing stuff, Vladimir. Yeah, I will be doing that as well. I'm just trying to do a diagnostic kind of approach right now, if I can. It could be something that's not suited right, but I'm just looking at things I'm finding as I find them. In fact, there's nothing at all on display. Shows it could even be the display itself. It could be the VFD is knackered. It could be it's leaked and it's no good. It's possible. So what I might have to do next is actually, like I say, unplug it and reseat stuff. Make sure the connectors are all cleaned up. There's not just a bad connection somewhere. And then I have to look at probing things to see what voltages we get. So we've got these, obviously the columns and rows on here. So that'll probably be columns, this will be rows, or something like that, I'm guessing. There will be details in it somewhere. I could just read the description. So I should be able to measure. Yeah, got PNP and NPN each side. So they're pulling to this 5 up rail there, minus 175. So these are pulling minus 175 in this rail on these sections here, and these sections are pulling 5 volts on those ones. So if I unplug the display output, I should measure those voltages and see if it's actually trying to drive the display or not. Oh, okay, that's what we talk about. Power supply section, right. Anyway, let's try resetting some stuff and we'll do some voltage measurements around here. But yeah, at least the thermal camera actually showed where there was a high voltage area. You know, there's a diode here, which is obviously the Zener diode, which is doing that high voltage drop off, and that resistor there is in series with it across that rail. So I believe this connector here is the one we want to take off. It's all gold pins and everything. Fortunately, I can't probe into there very easily. Not at least not with these ones. I have to change my probes. I do have some needle probes I can use. But there's obviously power going to the board because otherwise it wouldn't be getting warm in that area. So let's wiggle it around a bit. Make sure it's seated down. And I'll flip it over and make sure the other connections are also done from the CPU side. Not worried about the GPIB side, that's all, who cares, doesn't matter. There's also, yeah, the ribbon comes over to this side, which then goes around to display. You probably can't see what I'm doing. That's switched over here, so that's cool. It was switched over this time. So the ribbon cable comes across here onto the chassis over here, which then runs that way and feeds onto this board. So it could also be an issue on this board itself. Unlikely though. I believe it goes straight to the VFD. It might be using these chips over here as well. I don't know. I don't think so though. I think it goes straight to the VFD. But we'll reseat the CPU side as well. Do all these. That's latched down, but of course it's latched down. Let's pop that out. Get something I can use to spudge it out with. Okay. The other units of these I had didn't have these latches on, they're already broken off, they were missing. So let's plug those back in again. I don't think it's anything to do with these, but there's no harm in doing it. No, the latch won't latch back on. Go on, latch back on, there we go. This one has fell off. That's effective. Now I did the other units, I also reseated every single IC on the boards. Every single board had the ICs reseated, every one of them. So there goes GPIB, it shouldn't matter anyway. It's also loose. You can see why these don't end up being in all these units, because they're just falling off anyway. That's falling off. These again shouldn't be an effect of it anyway. Right, let's reseat this one as well, which is the power supply to this board. Okay. So all these capacitors here are likely bad. Very likely to be bad. And I should be recording this. So I was going around and reseated a whole bunch of connectors of the relevant sections. I haven't done all of them, but I've done a bunch of them. So just to rule that out, we'll see if that does anything. If not, we'll try and measure some voltages down here and see if it's trying to drive voltages to the VFD or not. I'm hoping the problem's on this board. Turn it on. Still on display. Oh, I'll turn it back on the other way. Yeah, still on display. So that didn't solve it by reseating. So let's keep looking. There's my needle probes. It's hard to figure out which pins I want on this connector now. That's the next thing I need to do. Right, come back to the chat. How's the stream going? Behaving? No? Imagine watching a PowerPoint presentation. Oh, that's bad. This isn't going well, is it? Damn internet connection. I'm afraid this is as good as it's going to get. I don't understand what's so bad. Right. I suppose what I could actually do is actually take the front panel off and see if the VFD's got a crack in it. Because I might be chasing something which isn't there. What screws do these take? Cussed. Alright. So I'll just take the front panel off and just check the VFD, and we'll see if the VFD's got any physical damage to it. Just in case that's what's wrong. In case I'm trying to diagnose an electrical problem and actually there is a physical problem after all. So this is a nice simple check. See if there's a crack across the front of this VFD or something. You never know. The back of it looks okay because it's got like a little nipple on the back which is used for sealing it when they gassing. That looks okay. So we'll check the VFD itself out physically in the front panel. Oh yes, that's what's wrong. Damn it. VFD is cracked. Big crack right from the middle of it. That's how I should have started, shouldn't I? Eh? Damn. Bugger. Oh. Well, this is a bit of a shame. That explains why the VFD doesn't work. Well, this is going to be a bit of a longer term project then, isn't it? Yeah. Big crack in it. That ain't going to work. That does suck. Electronic faults I can fix. Broken VFD, not so easy. My guess is that it got dropped or something, or no, who knows? You know, who knows what's happened to these things in their life. I wouldn't rule it out yet, Adam. Just because the VFD is fried doesn't mean I can't come up with some workaround. If the rest of the unit works, then you know it's. Yeah, I mean, when I purchased this thing, when I bought it, it wasn't working. Right, it was dead. The description was doesn't power up. It had the blown fuse in there. Maybe that's related to why the display failed. You know, display may have failed, then caused some kind of voltage surge or something from the display, and then caused it to blow the fuse. Maybe someone put a blown fuse in to hide the fact the display was knackered. Don't know. Maybe. But yeah, having a bad display, that's a bit of a downer. But it's not the end of the world. Because now I've just got a new kind of challenge. I like a challenge. So, oh well, that's no, after I did the electrical test, hold on, let's just switch this button. Don't need to flatten the battery on the meter. So that's what I should have done at the very beginning, I think. Just take that front panel off and inspect that. Yeah, that's what I should have done. I should have inspected that VFD. That should have been the first thing I did, actually. Future note, check the VFD first. Could save some time. Yeah. Hey, if someone could find a display for this, I'd much rather swap the display and keep it factory. You know, keep it original. So if someone can find a display for one of these, let me know. I've not yet. I could look. Has the VFD been swapped out before? Well, the seals are still on the casing. It still had the seals on it for calibration, so my guess would be it got dropped sometime with calibration and then, you know, sold as is. Yeah. Well, I'm going to have to have a look for VFDs. I know they're hard to get. Usually you have to get them out of another scrap unit. So I've got the other unit which does work, and the VFD does work on that one. But yeah, if it's an electronic fault, you know, that's my hope, is that it's something to fix electronically, you know. But as it is, the problem is for this particular unit, well, this style of unit, is that the gap between the display and the front panel is about that big. It's small. So there's not much room to actually get something in there. Yeah, that's right. I was saying before, Christian, Feedback Loop has done videos because he had the same problem. I think he had a really weak display, I think it was, I'm not sure. And he replaced it with a whole bunch of little displays stacked up side by side. I know he wasn't completely happy with it. It worked. It did the job, but he wasn't completely happy. I think he did another one as well using discrete LEDs. I think he did OLEDs, and he did some with some LED displays as well. I think I saw that one too. So how do I go about fixing this? Voltage conversion. Well, it's just pulling high voltage transistors between the power rails. So it's still got rows and columns control. One's for 5 volt supply. One is of a minus 175 volt supply. So if I were to simply change the minus 175 to say 0 volts, modify display board, make it a 0 volt rail instead of a minus 75, then that would allow it to be switching the negative side, and then I can use the row and column as drivers onto a conversion system. So how many outputs we got here? 2, 4, 6, 8, 10, 11 from there. 2, 4, 6, 7, 8, 19. So if I just basically adapt into the output of the board and then decode it and then recode it into a different kind of display. Let's switch views again. Or I could take it straight from digital logic up here. So I could either use the driving from here and convert all this, or I could tap into this section here where it's got the actual driving from these devices. So you got this IC here. That's got. Let's have a close look at that. This looks like it's got a hex input. 1, 2, 0, 1, 2, 3, 4, 5. I don't see 6. Curious. I don't see 6 or 7. It goes 8, 9, 10, 11, 12. Why is there no 6 and 7? So that's got probably a 7 there. So that's probably polling these. So microcontroller doing conversion. Looks like it's in, is that a multiplex of some kind? LS157? Yeah, it's going to take a bit of figuring out, but it's not insurmountable. I could either tap off these directly, or I could tap off these by the looks of it, because these are obviously the input to this particular chip. And then that only means I need 4 pins on now. I can do decoding within the microprocessor. I wonder what's polling this for. That's interesting. Or I could tap off these lines here. Yeah, I have to reverse engineer this to figure this out. Because obviously you've got multiple sources. This may be ranges or potentially mode switching, which is then added in. Is that an adder? I'm not sure. 74LS157, let's look that up. The number sounds familiar, actually. I'll check the chat in a second. Input multiplexer. Hey, I was right. Okay. Appears 7-segment multi-digit mux. Yeah. Yeah, it's got different. I know it does drive the segments. It does the modes and ranges as a column. I think it's what I remember reading a while ago. Yeah, so it's got it displays the digits, obviously the numerical digits, up to 8 digits on display, but obviously this particular unit doesn't use that. It's only going to use 6.5 digits, so 7. Plus it's also got ohms, meg, amps, volts, millivolts, milliamps I think's on it, and AC. I think it shows AC waveform as well. So it's got a whole bunch of characters on there as well, so I can't just use a standard off-the-shelf VFD if there were something which fitted. It'd have to be the right one. So I'm looking at, because I'm quite comfortable writing code and making conversions, I'm looking more at making this interface to a microcontroller to decode it and then use that to drive a different kind of display. Whether I can get a display which will fit in there with a good resolution and stuff is a bit different. I mean, you want them to keep a nice look, but the first thing I'll do is try and find a replacement VFD. If I can't find a VFD for it, then I'll look at doing a conversion. That itself could be quite a good video, I think. Yeah. So yes, it's going to be a bit of a challenge. Shall we look into this now? Let's try and figure out what it needs. So we've got direct digital over here. Those NOR gates, aren't they? I never remember the bloody symbols. Those NOR gates. I think the NOR gates. Yeah, I'll make it bigger so you can see what I'm talking about. Now I've just shrunk it down a bit. That's a NOR gate, isn't it? I think it is a NOR gate. So that will be switching these ones. So what does it say here? Segments. These are segments. There you go, it says segments in here. Here you go, it mentions the digits. There you go, these are the ones which are doing the actual ranges. So that's AC minus volts, ohms, K meg, plus milliamp, something there, I can't see what that is, M percent. Okay, so it's also showing those ones and the segments as well. So that's as it goes through, that's treated as a column. So A, B, C, was that A? That's E. What's that on there? Is that B? That's B. So A, B, C, D. That's B. What's that one then? A, B, C, D, E, F. There's H. It must be G. Okay. So that's segments. And that doesn't say. So this must be digits. Yeah, NOR. Yeah, cool. So I was reading the chat. Yeah, I'm still physically limited by the size, and that's going to be the challenge. So, something you got sitting on my desk right now, somewhere. Here it is. Is this also cracked display? I purchased this. This is in my mailbag, which comes up in probably next week. Yeah, not tomorrow, but next week. I purchased 4 of these, and one arrived cracked. Be cracked to it, but I don't think you'd be able to see it on camera. Maybe you can, maybe you can't. Bit disappointing, but yeah, it wasn't packaged very well. So something along this kind of line. This is a nice TFT, colour TFT. Obviously, this is too big in this particular case to fit in here. Height-wise is good. Height-wise will fit in there. Just, it's really close. All right. If I took the SD card mount off it, you know, it'd fit in there. That direction is a bit big. So, but you can get much smaller ones than this. So, it might be possible for me to get some VFDs like this, mount them end to end, just have 2 displays back to back. They run off SPI, and I could have one VFD doing one stuff and the other one doing the other one. And I've got to cut the end of the board off or something, so they can go end to end and have a really small gap between them. I might be able to, you know, make that work. Or I just put all the digits on one display and all the enunciators on the other display. But yeah, this is a 3.5 inch, but you can get these down to like 2 inch, stuff like that, quite easily. So if I got some smaller ones of these, I might be able to build a new display up for it, and then use probably an ESP32 because of the power of it. Could probably use an Arduino, but ESP32 is more likely. No, I have to think about it actually. What controller I'll use. ESP32 I think is a bit more friendly for it. But yeah, replacing display isn't insurmountable. It's doable. It's just interfacing onto this board, and it looks like it's a case of just figuring out how to reverse engineer the actual symbols and stuff like that, and the control circuitry. Because this bus over here be the one that comes from the microcontroller, which is what tells this stuff to work. So MC14515BCP. I saw that on a diagram as well, but yeah. So it's a shame, but hey, these things happen. Yeah, then I could literally get rid of the high voltage end at this end. Yeah, I don't know. I have to think about how I interface stuff like that, but I'm trying to think about the big picture side of it as well. Common anode driver for digits and cathode for segments. Yeah. I mean, yes, I could make something using discrete LEDs. Service mount LEDs and a circuit board, which I can get made for nothing because I'm going to get sponsored by PCBWay, so it wouldn't cost me anything, only the parts. Like a 3D print a bezel to go around it. All that stuff is possible, but then I still need to do a conversion system and a way of driving it, and you know that's going to be the bigger job. And to me, it's probably simpler to use some TFTs or something like that, or OLEDs, than it will be to make a LED system for it. So that's what I'm thinking about, is what's actually going to be the better route, or route, how you want to pronounce it. ESP32 is like shooting flies with a bazooka. Yeah. Yeah. Well, STM32 I don't have any. I have no experience using them. Not a clue. So all my stuff I do in the Arduino IDE. That's my limitation. And although I don't know if they're programmable in that, I don't know. But then I have to learn maybe the quirks of that particular device and how to use that. Whereas I've got a whole bunch of ESP32 boards here. I've got a bunch of different ones. I've got a whole bunch of Arduinos. I can use it like a Pro Mini or something, I don't know. But, it just needs to have SPI support. And you can always bit bang that. Yeah, 2/7 segment, yeah, that's right. 7 segment display is what it's based upon. Yeah. Oh, great. Someone's got their bike going. Hopefully he drives away. PICs again. PICs, no experience with PICs. I've never used a PIC. Yeah. So, because I'm using what I've got, you know. So, what I'm familiar with, I don't know. Yeah, I think before I look at that avenue, though, although it's tempting to play with that and actually to dive into that section of it and do the reverse engineering. That is very tempting to go diving into this. I'm inclined to try and source a VFD first. It'll probably cost a lot more, but if I could find one. But it keeps it factory, which is, I kind of like to keep things factory if I can. Let me find the circuit description for this thing. This probably don't drive the bloody streaming wild, jumping through all these pages. I don't know where it is in here. I'll find a circuit description and see what it actually says about it. It's a lot of pages in this thing. We'll read the circuit description, then we'll see what we can come up with from that. That's the control systems. I don't think this is just the interfacing between the boards. That's not in that bit. If I started at the top, it might be a bit better actually, but Anyway. Where are we? Come on. Display driver assembly. This bit we're looking for. Let's go up a bit higher. That's the keyboard display section. Let's make sure it's not related. Display signals. Gas discharge display. There we go. That's what it calls it, rather than the VFD. Not interested in the keyboard side of it. Because that's all separate, even though it's on the same board. Display driver light circuitry, here we go. So M1's RAM. Okay. So it must be loading into RAM then clocking it over or something. Clocking through addresses in order to produce the output for each digit or something. That makes things a bit more interesting. And here we go. Display block energized. So it's clocking through each RAM address to do each section. And there's the sections. So yes, this is a bit more complicated, but not that bad. It's still doable. Let's read the chat again. I think STM32 can be done in Arduino. I think it can. It does sound familiar. But again, I don't have any STM32s anyway. And then you've got to make a circuit board to put it all on and stuff like that. Whereas the ESP32s I've got are already on development boards, you know, the plug-in modules. So it's simple. How fast is Spain to be refreshed? Don't know. Well, I mean, if it's on a TFT, it will just update periodically. It doesn't have to be quick. TFT or OLED, and both will be pretty fast. I think TFT is faster than the OLED, I'm not sure. Because we're using the OLED in some of my projects. I know I've used TFTs as well. We use them both, but for different functions. It's the update time of sending the data across the bus, which is what restricts it, I think, mostly. Yeah, exactly. If I use an ESP32, of course I network it. Instead of using GPIB, I could send it over a serial connection or something like that instead. Can I scope it? I could. But it is high voltage. I want to be a bit cautious about how I handle that. Yeah, I've got lots of options, eh? That's the thing. Which way do I go with it? Because it is being treated like a 7-segment display. AbleSki, open circuit electronics. It's descriptive. Having a descriptive name is quite important because people then know what to expect from the channel just by, if it's just your name, for example, like John Smith, for example, no one really knows what it's about. But if you've got a description of what the channel's about in there, what its context is, then it helps. Okay, so I'll just try and get my head around this. So that's 1, 3, 5, 7, 9, 11, then 2, 4, 6, 8. Because evens and odds. So it misses characters, then goes back and fills in the gaps. I suppose that's so you don't see that whole scrolling effect, or hide that. So 10 and 11 are treated as digits as well. So it's effectively 11-digit display. And a reset counter as well. Interesting. So yes, it's obviously dumping the data into RAM, then loading it back out of the RAM depending on the counter point. That's how it's working. I mean, if I take it off early enough, I won't need to worry about the RAM section. I could just not use RAM because the microprocessor could handle that. It will just store it as a variable inside the microprocessor. So it's dump it in there into each variable as a variable per digit, and it will just fill it in as it goes. Obviously, it clocks in per digit. So it's got 8-bit coming in. So it's doing 8 bits per digit, and then clocking across each digit to load it into RAM, and then playing it back out again. Or is that multiplexing it out? Got read write switching. So there's base block. Buffers, drivers. Two kilohertz. Got 2 kilohertz coming in here to the counter. That's a clue. So it's decoded and clocking the RAM at the same time. Right. Let's read the description, shall we? So trying to work it out from diagrams. Chat again. Oh, yeah, definitely high voltage won't be too good on there. My 5-volt CPU, or MPU. Yeah. SPI, stateful packet inspection. I don't even remember seeing that setting in my router. Router, whichever you want to pronounce it. Don't remember seeing it in there. Because I live in a rural area, and we don't have any fibre or wired broadband here. There's no ADSL or anything like that. There's nothing like that. Anyone here that's got broadband is wireless, and it uses, I think it's 5.8 gigahertz, something like that. And originally when I first got it, I was actually the first one to get wireless broadband here. Nobody else had it. And then other people have gradually been getting it. And as more and more people have got it, my service quality has got worse and worse and worse. So, but the fact that the 4G network is also struggling means it's more likely the 4G network can't handle the bandwidth, because it's probably running through fibre, which is the same link, might be from the same network hub or something through fibre. So maybe the whole network can't handle it. I don't know. Replace the VFD driver with a ULN 2803 and drive them directly. Yeah, if I'm using a 7-segment display, then yes, that will be a way to go. So just convert the voltages and drive it as a 7-segment display. But I'm also thinking about number of input pins. So if I'm using a microprocessor, I don't want to be using 19 pins or whatever to translate the data into it, to display it on a TFT or something. So in that case, I don't want to shove in, well, it's got 12 pins minimum, it's got 8 of binary data going in there, and you've got the 4 other lines as well, which are clocking it over, so you know which digit it is. So, although I could just maybe, I don't know, I can't detect the state changes. Maybe I do it that way. So I have to tie into the counter. So that's like 12 pins versus all the pins for the VFD conversion. So, yeah. Blocking adult pages, but no, I don't want that. Anyway, yeah, so I've got options. I'm not stuck to one particular way. So anyway, let's read this thing, shall we? I haven't actually read it yet. Can you guys read that? I don't know if it's big enough. Make it a bit bigger. Microprocessor runs 800 kilohertz. And it's read out at 2 kilohertz. There we go, there's your answer, Ian. It's read out at 2 kilohertz. So that first paragraph covers it quite nicely. So it writes it in. Okay, so puts in the right mode, loads it in. I'm a slow reader, sorry people. It takes a while to absorb. Hope you guys are reading this too, not sitting looking at me staring at it. Right. So. I do find it interesting when I load it to RAM, then read it back out again. That's a bit of a interesting way of doing it instead of reading it directly in. I suppose it allows the CPU being busy, and so I can't actually send the data out fast enough to keep the display active. Maybe, I don't know. It's always holding something on display. I'll read the chat again in a second. Yeah, okay. That's into that. So yeah, it's just reading its RAM, reading back out of RAM, and that's it. Okay. So it shouldn't really be that hard to make something. Not really. Okay, let's read this. Driven us 2 7 segments. Oh, yeah, hold on. I think it's driving each digit individually. Just that counter here changes. So yeah, it's just overlapping them. This is a 1062, but it'd be exactly the same board in 1061, 1061A, 1071, 1081. It's the same board. It's all identical. Same display, same board. These are across all the models. I think it might even be the same display that's used in the calibrators as well. I think it's the same one. In the right hand display in the calibrators. So I think it's pretty much a universal display in all their models. They use the same one for everything. Okay. Yes, making something's quite likely to happen. Let me have a quick look and see if I can find a VFD. You never know, I might get lucky. I highly doubt it, but let's jump on eBay. Let's have a quick look. You have to go to eBay. I don't think I'm going to find one somehow. Although it's called a gas discharge, so I'll look for that name. And if I spell it correctly, that also helps. There's gas discharge displays, but not for the Datron. At least not what I've seen yet. Yeah, Panoplex displays. I think that's what they call it, Panoplex. There's a 3-digit one there, which isn't obviously not right. A couple of those. What's that one there? Gigatronics one. Not right, but similar, but no. Rohde Schwarz one. That's not well, nothing on eBay. Let's call it a VFD. See if it comes up under VFD. Why did that just download something? Need to push the right buttons. And no, it's brought up a whole bunch of watches because of Datron watches. That's helpful, isn't it? No, nothing there either. Okay, so no VFDs currently available. Or, I don't know, it's gas discharge, is it? Gate GDD? GDD? Let's try GDD. Probably come up, God knows what. Watches again. It's annoying. It's called, named after watch, or watches named after. I don't know. Anyway, so no luck there. Phase detection on decoder column row drive multiplex signals. Yeah, I'll have a look in a second to see if I've got any markings on it. Yeah, it's probably got it in the listing in the bomb. I could find that as well. It's actually just here somewhere. It's actually not far off the bombs. It's pages and pages of it though. We have to find the right page. It might be marked, but it might be on the back of the display, where I'll have to take the display off to find it. Well, I'll probably have to do it anyway. Front PCB assembly. That's sort of on the first section here. There's ICs, switches, various parts. That looks like hardware. You go, enough digit display, Dale. That's all it says is Dale. There you go, just here. And that's a Datron part number there. Yeah, that's helpful. No part number on it. Let's have a look at the actual unit. I don't think it's on the edges. I think it'll be behind it if it's got anything marked on it. Yeah, there's nothing on the edges. That's a shame. Alright. So yeah, trying to find one that's going to be not likely to happen. So, bugger. That's a shame. Would have been nice to be able to find a display and drop in your display. It would have been simpler. Although there's lots of pins on that display to get off. But, that has to happen anyway. That has to be done if we're going to replace it. But that's alright. So nice little fun project to make a replacement. Who knows, maybe I could open source it or something, make it so other people can also make them. I'll do something like that. Yeah. Vishay Dale, was it? Oh, okay. Well, I mean, I saw reference to Panoplex as well. I've seen, I think I've seen called Panoplex displays as well. I've seen that mentioned. So I don't know. Right. Well. I'm kind of stuck with this one now. I can't do much more until I start to actually reverse engineer it properly and figure out its design. Yeah, so at least it's well documented in here. It says, you know, how it works. It's all, you know, basically a 7-segment driver, as you know all seen. So you found a dial part number already. That's impressive. I doubt you'd be able to get them. Discontinued, yeah, sure enough. From Mauser. Plasma display. It just says discontinued that page there. I'll just put the part number in. Yeah, okay. Nothing obvious popped up anyway. So Panoplex will be by Panasonic. Okay. Yeah, because I've heard it mentioned as Panoplex. So I don't know if there's discontinuation notice. That's right. Yeah. Well, I think what I'm going to do with this is I'm going to find some displays which will fit in that space, and I'm going to make a new one, because I think the chance of doing that is far better than me finding one of those displays for a reasonable price. Because I mean, if I can get some TFTs for like $20 each or something, 2 of those, I've already got ESP32s. It won't cost me anything to do in conversion or Arduino, you know, whatever. I've got Pro Minis, Pro Micros, whatever. I can use that to convert from the LCD, like 7-segment drive displays, to drive it to the TFT or OLED, either a TFT or an OLED. I think because it's got to go through that display filter, it probably needs to be emitting light more than TFT might. I think OLED might be the way to go. TFT has high resolution, means I can have more control of what I display. OLED will be potentially brighter. Yeah. 2012, so yeah, it was 8 years ago, no longer available, yeah. So yeah, I think that's what I'm going to do. I'm going to come up with something for that. I'm half tempted to try looking into it now. But I need to concentrate more. When I'm trying to live stream, I can't concentrate as well as I normally can. It's very distracting. Very distracting. So it makes it really hard for me to concentrate on what I'm doing and actually involve myself fully in it, as it were. So I probably won't do it whilst I'm live streaming. So what I might do then, should we try and find some displays? Let's get AliExpress. Jump on AliExpress. Interesting web pages load fine, but my streaming's struggling. Okay, let's change pages. Well, change views. And right, let's do this. Okay, so I want TFT. What size gap do I need in here? Let's have a look. It's probably going to switch views for me, you know. Maximum height is about 4.5 centimeters, and length is about 17. The display window is obviously smaller than that. So if I use that as the data point, so 4.5 was about there. So yeah, I've got basically a 25mm window, 25mm window, and that is about 17 centimeters long. So this doesn't have inches on it. Let's get this rid of this has inches on it. Let's look for a effective diagonal size, because that's what they're measured in it usually, diagonal. So if I assume 2 displays, so I go about halfway, that's about 4 inches that way. But I think 3.5. Yeah. But because it's got to be a narrow display, I need to get one which is elongated or smaller. So that's a 3.5-inch display on here. And that's obviously way too big to fit in that space. So if I've got, say, a 2.5-inch display, that would be closer. I have some 2.5-inch OLEDs here, actually. Let me get one down. Also, it's climbing on my desk, so let's move this out of the way. And hopefully I don't fall off a chair while I get one down. I do have some displays here. I have a small stock of displays. A small stock of displays. And bits and pieces. We've got here. There's a standard LCD display, don't want that. These are the same as that one. This is a smaller one, I think. Is it? No, it's the same. I don't even see what I'm doing here. I've got some OLEDs in here somewhere as well. What's this one here? That's the same physical size, I think, as that one. Yeah, it's the same screen, just different format. Where are we? So here's the OLEDs. So unfortunately, they've got a big border around them, so you can't get them end to end. But they will fit in that space. These use SPI or I2C. I can use either one. When I've been using these before, I've actually been converting to I2C. But obviously the display size is going to be significantly smaller. That's the drawback there. They'll fit in the space. Yeah, I mean, I don't like the fact it's got a big border on it. That's going to be a problem. I could take it off the board itself as well and just run the flex around. Could do something like that too. So I can get the boards closer. Could probably put a spacer between it or something like that and step them out. But I'm still going to have a big border. Don't go right up to the edge of the actual metal there. So yeah, I'm thinking TFT might be better because of the issues of trying to implement these ones. These are 2.4 inch. So I think I need something in between the two. Actually, it'll fit in the space, but I think I need to find TFT. I thought I did have some smaller TFT somewhere actually. There might be some in that box actually. Ah. Hi Peter, how's it going? You made it? Ali has longer OLED. Yeah, they've got quite narrow ones, haven't they? They're like the ones I've just showed you, but they're half the height. But the only problem with the OLED is that the resolution is nowhere as good as a TFT. The TFT's got really good resolution, like the ones I've got here are 320 by, well, 480 by 320, something like that, I think they are. Whereas the OLEDs are only like 64 by 128 or something like that. Much lower resolution, which means you've got much less options about what you can display. Where did you find that, Vladimir? .12 inch 256 by 64. That sounds plausible. 25564. Oh yeah, those ones, yeah. Okay. Trying to find myself, not trying to sell me 100. Yeah, the thing is, I've still got the issue with the border around the outside, haven't I? It's the only problem. Like, we've got that bigger screen. Because I could use a bigger screen, just not use all of it. I've got to choose like the middle of it. And that would be similar to these, but let me have a close look at one of them. Let's change views. Oh, go away. These bloody coupon things popping up all the time. It's a pain. Right. Come on, you're going to open it up or not? No, not to like. Okay. That's a 2-inch one. I've obviously got the wrong one. Where's the bigger one? It's got a good resolution, but 2 inches. So that'd be about right for fitting the window, wouldn't it? Kind of. 19 high, so it's actually too small. It needs to be bigger than that, yeah. So where's that one you said? 3.12 inches. Is it showing up in here? Because I put that part number in you put in. Alright. Weird. Okay. So I'm going to put that code in there. that in, see if it finds that. Here we go, 3.12, that sounds better. Okay, that's the one you're meaning. Well, right, that's why the number's from. 2564 dots. But again, it's got the border issue. 33 high on the board. So the display's going to be slightly smaller than that, probably about 20 high or so. Just a shame about the border. Yeah. .21 high. There we go. Display height is 21. But I'll display slightly less than that because it does have a border internally. Was that say 19? Is that 19.18? So 19mm high. So it's actually a bit smaller than I'd like. I want slightly bigger than that. So if we can get that format, that elongated format, but in a bigger size, so that size but 4 inches, in a long format rather than a rectangular format, that would be good. So let's try 4 inches. Let's try that. Who knows what's going to happen? No. 3.5 inch. No. Yeah. Anyone got any leads? So there's that Panoplex thing again. Yeah. Why can't I select this text? There we go. That's going. So Peter, what you missed if you weren't around, this Datron has a cracked VFD, or gas discharge display, which you want to call it. Nothing's come out there either. So yeah, we're a bit out of luck on that one. So I'm looking at what I can do to replace that display, and let me have a look here. Let's put this back down. I've got my windows overlapping because the OBS jumps at the front, so it covers things up. So it's annoying. Okay. I was trying to find out what that one is you say you've got there. I've got to find it. Yeah, they look different anyway, I think. Yeah. So you could actually stack multiple displays, couldn't you, in order to get the right number of digits? You could do that. Yeah, I think I'm going to go with a re-engineered route, and if I either get exactly the right one or I just completely change it, so I don't have to worry about that ever again. So I need to find an OLED or TFT which will do the size I want. So let's go 3.5 inch TFT. What's that pixel resolution going to be? 160 by 480. Let's try that. See if there is anything. It doesn't look like it. Let's shove this back up the top again, shall we? Let's see what I'm looking at. Yeah, it's only coming with standard stuff, so 4-inch TFTs, try it. Sometimes you just chuck random things in and you'll find something. Sometimes. But not that often. Unfortunately, it's finding a standard. It's 2.4 inch. Yeah, it's not looking hopeful, that kind of system. You've got a mouse apart number, have you? Well, I don't want to be doing anything which involves messing around with flex cables, you know, those little flat flexes, stuff like that. I don't be messing with any of that stuff. Well, and I just found I had a second window open, just playing my stream back on my other browser. I've got 2 browsers running. I wonder if that helps my stream speed. Just sitting there quietly playing back with no audio. That's helpful. Okay, let's look this up. When it eventually loads. Okay. It's going a bit slow. No. Let's try it this way. Okay, here we go. What is this one stated as being? Viewing area 23mm high, 150 wide. Now I said, what did I say it was? 17 wide, the window. So the viewing area is right. Okay. Oh, that's a 2-line display though, isn't it? That's just oh yeah, standard like LCD display. Just a standard 2-line LCD. But what I like about the other like OLED displays that I've been using is that you can put the characters anywhere you want. You can shift them anywhere. You can just tell it a XY axis positioning. And it will put the text right there. So it means you can put anything anywhere you want. And you can just like blank display, write whatever you want anywhere on that screen, and that's it. So it gives you lots of flexibility with these 2-line displays, although this does look basically right size, so well done finding that. You're a bit restricted because you have to be within those 2 lines. And you can only do in those 2 lines. So at least that's my experience with it. If someone knows another way of doing it, let me know. But I believe they're pretty much just individual, like treated like 7-segment, well, multi, it was a dot matrix display sort of thing. Yes. Yeah, so it's the right dimensions. It's exactly the right size, but I need that in a TFT/OLED size. So close. Yeah, if I put this multiple displays in there, there'll have to be a gap between them. Yes, will be something. The TFTs to come closer to the edge, so the gap will be smaller. OLEDs will be a bigger gap, which is potentially ugly. I have to make sure the digits don't overlap those or something. Or no, awesome, the bike's going again. Well, I choose to make noise while I'm trying to stream. I don't know. Anyway. $770 display. Yeah. Let's check this window. Oh, right, it's not a bike. It's the guy over the road. He's obviously flushing out his engine from his boat. His little boat engine. He's obviously flushing it out. We'll probably shut up again in a minute. So you reckon 7 segment LED digits. From a replacement point of view, that'd be more of a drop-in idea. It'd definitely drop in with less modification required. Is it as much fun? I've done an 8842A. Okay. I've got an 8842A. I've actually got an 8840 as well. I think it's a 4040. I can't remember. I've got a junked one up on my bench up there. On my shelf up there in the corner. Been sitting there for a couple of years. I bought it. I bought a few of these things. I actually sold a couple of them after I fixed them. The 8842As, and I used the 40A as well as a parts unit, I think. Was that one had a bad board? That's right. And I was trying to fix something. I actually made it a bit worse. Made a mistake. So I gave up on it and just chucked it on the shelf. I might use it for parts for something one day. But I think it's got a good display on it, so I'm going to keep it for that. Yeah, 7-digit LEDs. Well, 7 segment LEDs. Let me check the height. See how much height I've got on that front panel. That's the measurement I haven't actually done. Actually, I won't use this one. Oh, I think I might have to use this. The PCB rulers don't go right to the end. So the height is, using this thing, 9mm. Let me get my get this out. This might be better. .7mm. That's the height, and that basically touches the back of the panel. So I mean, I've got some LED stuff in here actually. Let's just measure one. I've got a block of 3-digit ones, are they? Those individuals. Those 2-digit ones there. These measure 7.2 with no board. So if you put a circuit board on the back of that, so that's going to be another 1.6 at least, minimum. That's 8.8. That's like right on the limit. That's with no solder on the back of it. That's a bit thick. That's a bit too thick, really. Using off-the-shelf modules like that. Yeah. I would have to think about this. Other stuff in here because I've got, because I do have some of these standard displays in here like this, this kind of thing. I do actually have quite a long one as well. I picked it up as a, where did I pick that one up before? Something I don't even have anymore. I actually sold the thing. Here we go. These. Got these things, but again, the height is a problem. That is going to be way too big. So that, if I literally, as we stand off, that's, I don't know, probably 3, 4, maybe 5mm. Probably about 5mm too proud. That board like that. So not an option, not in that case anyway. Yeah, but I got this for, I think it was the HP 8647 or something I think I had. I mean, it's kind of like the right size. It's just a shame about the other dimensions, you know, the thickness and stuff. So that's a bit of a problem. What displays have we got on here? I've got all sorts of displays shoved in here. And those standard types. Is it another OLED? Is. Yeah, I know, it's standard ones. Yeah, I think that's pretty much the extent of it. Yeah, it's a shame. You know, the physical mountings are a restriction, but a TFT display, some of that will get in there because they're pretty small. So, yeah. Let's go back to this. That one. Not as high tech, but yeah, less effort definitely would be. Extra AC option board. Well, I'm looking at the height of the PCB itself, so I'm going from the PCB, face of the PCB, to the back of the front panel. That's the gap I'm looking at there. So, because of the VFD basically rests against the back of the front panel, part of the reason it's broken is because it actually touches. Any impacts on the front will hit the VFD directly. That height was 8.6 mil, wasn't it? Something like so, not much room to get something in there, but a TFT display on a board will fit in there. The height is good enough, it will fit. What's that part? Let's have a look. DSM. Come on. Let's have a look on here. Once it loads. Okay. (12 by 20 by 2.1), so 12 mil wide, 20 mil high, which is okay. We've got up to 25 max, so that fits. 12 mil wide. Ooh. I've got snacks. Wife brought me any coffee and some little maintenance things. Yeah. Drop crumbs on my keyboard. That's not good. This just goes off. Right. Okay. So that looks actually pretty interesting. 12 mil wide. So I need 7 digits. Plus a plus minus symbol as well. Although you don't really need a plus, you need a minus, because if it's not a minus, then it has to be a plus, doesn't it? So therefore you only need a minus symbol. So if I say 8 digits long, that gives me the 6.5 digit display plus a negative symbol, and then whatever I need to do at the other end to make the symbols, which I could maybe use a small OLED for. It's a coffee. Got a coffee. Hi David, yeah, yes, right. I did see those videos by Feedback Loop. I watched those a while ago. I don't know, 6 months ago. I think I looked at them, something like that. So yeah, I did know that he'd done He's faced the same problem, and his solution, he tried a couple of different solutions, and he wasn't 100% happy with the ones he ended up with. And he got it working, but he wasn't happy with it. But these look quite good. So these are 12.5 wide. Can we get a closer picture? Reference only. Hold on, let's get data sheet. Okay, so it goes right up to the edge. Okay. Surface mount pads, castellated pads, that's okay. Getting boards made, not an issue. The thickness means green, different colour. Because orange is the original colour. If you get orange ones, it'd be good. But sometimes you can't be too fussy about these things. So 12.5 wide. So I was trying to figure out the maths for that. So I need 8 digits long. 12.5. That's 100 mil long, exactly, just for those digits, which is good because it leaves me space still to do a secondary display for the enunciators. So the current one, so 100 mils here, so it'll actually be slightly shorter. The resistance display comes down to here. So it's not too different, it's slightly smaller. The enunciators is currently about 40 mil for the enunciators. That's fine. So it'll be a fraction smaller, but that doesn't really matter. It's still going to be big enough. That's looking like a reasonable solution, actually. Did I have it in the orange ones? If they had orange, it'd be perfect. I'm guessing they've got a similar part number for the orange. Cockroach mounting. Alright. Oh, I'll switch views. Why does it switch views? I didn't do that. Watch out for that. Okay. So, can anyone find the orange version of these? Is there an orange version of these? Well done, Peter, for suggesting those. That's good. $10 each. Wow. So that's $80 just for the digit displays. Well, if I get 10 of them, no, it's still $80. No. Okay. Oh, it's got a factory lead time of 8 weeks as well. Oh, damn. So the price is a bit of a concern for they're a bit high in price. And it's an 8-week lead time minimum. Plus, the postage time from overseas right now to me is horrendous. It's taking months. They have red. Well, red is not bad. Red's probably close enough. Oh. Never to be seen again. was looking at the parametric search now. There we go. What's this one here? What's this one? It's a slightly bigger, which is okay. I've got room for it. Oh, okay. They've got something stuck, have they? Right, hold on. Let's look at this other one as well. Here we go. Man, I've got expensive taste. These ones are slightly bigger. Same design. $79 in stock. Cool. Okay. $14 each. $12 each for 10. Where is it? This one? Yeah. So the digit height is 17. The module size is 24 high. I think we can go bigger than that. So that's 15 across. Get the calculator again. Hold on. We'll call it 15. So that's 120 millimeters long. So that's still an acceptable length for the display. Monetary wise, I'm not too worried about the financial aspect of it. I don't mind spending the money to get the result I want. If I can find a cheaper solution, great, but right now this is looking like the best solution. Kind of. I've still got to consider the enunciator section. I've still got to figure out how to do that part. Okay. The common anode displays. What was this thing doing? This is common anode. What was this unit doing? I can't remember. Was it common anode, common cathode? I don't remember what it said. Who cares about stuff? Packaging, yeah, whatever. Okay. So the pads have to be like 27mm high for pads, so call it 30mm for PCB minimum height. How much space we got in here? We have, was it 40? At least 40, 45. Say 45 absolutely max. 40 would be comfortable. Yeah. So we've got plenty of height. Digit size is what? Digits are 17 high. Call it 18 high. So the digits on here are, I get the reflections off it so I can see. I can't get the reflections off it. There we go. Digits on these are about, bloody reflections. That's driving me nuts. Because it's yellow tape measure. Let's do it this way. Right. They are about 16. So the digits on those are actually slightly taller. Okay, and what I say it was 120 long, wasn't I, for all 8 digits? So there to there, 120. It's the same length. So it's the same length but slightly taller. It's looking promising. You couldn't see what I was doing. It didn't switch over for some reason. Curious. Oh, because I don't have that forward, maybe? I don't know. It should work. Right. You found some white ones, $1.38 each. Okay, let's check this other one out then. Red would be okay, it'd work because it's got the display is actually a orange filter. It's the actual film is orange. So red would work, it would just be a more orangey red. White would also work, but it would be obviously, I don't know, maybe come out yellow, maybe. Which I think would look alright. Wouldn't be too bad. So those aren't bad. Let's put this down here for a second. Let's save that. Let's save that data sheet so at least I know a product I can look at. And bookmark that page. So at least I know that's an option. That's not a bad option. So let's look for the other one you mentioned. I've never bought from Mouser. I mean, because Mouser is basically US based. So these white, these are bigger. I think they're slightly deeper. So let's check these out. So they're 19mm high overall. Digits 14 high, so it's similar size to the existing ones. And they are 12.5 wide, so they're slightly narrower, so it'll be a slightly shorter display. Height is 3.5, well, nearly 4mm deep. So I've still got 4mm to play with, minus the PCB, minus soldering. It's close. It might just fit. And the price here I've got $4 or $2.69 for 10. That's not bad. So look. Hi Kim, how's it going? Haven't come up for you for a while. Yeah, I could do symbols with LEDs. Yes, I could do exactly that. I could indeed 3D print a bezel to go over the top of an LED in order to get the symbols. Certainly possible. I'd tend to 3D print and make a frame to house it all in as well, so it's all well like one unit. So that I'm not too worried about. It'd be a minor complication, not a big deal. And printing on overhead litter stuff, yeah, you could do that too, definitely. Use Mouser frequently. I've never used Mouser. I've used OS components, Element 14. I've used Arrow once. I was very happy with Arrow. They're pretty fast. But all these other companies, Element 14 OS components will give me, well, OS basically is free shipping all the time. Element 14 give free shipping if you've got a certain order value. Alright. Well, it's still cheaper. So, it's slightly bigger. Well, the package size is slightly bigger. But being surface mount means I don't have any through holes in the back, which also reduces a bit of the height. So it'll be surface mount on the front, which is better. I can mount everything off the front of the board. That way the back of the board can be flat, nothing on it, completely blank on the back of the board. I can just double side tape straight to the front of the existing front panel. And Express has them, does it? I think from China right now things are really slow. US is slightly better. China's taking months. Yeah. Things from iOS and Element 14 are pretty quick. They're doing okay. So if I can find this on iOS components or Element 14, that'd be my preferred way to go. Right. Let me see what I can find. Let's try iOS first because I have free shipping all the time. That's the only reason I use them. If I had to pay shipping on everything about the same amount, I suppose I probably will still use them because they're not too slow. Element 14 is faster than iOS usually. A lot of it comes from Australia. So let's put that product code back in again, see if it comes up by any chance. No. So I'm going to have to do a Silver Mount LED. Let's see what it finds. Some coffee. Seven segment then. Okay, let's do 7 segment LED. Right, LED displays. Let's go in there. And there's 466 products. Let's see if we narrow it down a bit. Number of characters. Yeah, it's got 8. There's one with 10 characters in it. Let's try that. Let's have a look at that one. 10 characters might just be boom, straight on, done. 100 mil. That's not what I want. That's not 10 characters. Yeah. Okay, can that one. Let's bring it back up here so you can see what I'm talking about. Okay. Mounting type. Silver's mount. That'll narrow it down quite a bit. Suspended mount. What the hell's suspended mount? That's a new one on me. Oh. Okay. Yellow. I could live with yellow. $2.60 each. That's alright. And a pack of 5. 7.6 mil. Is that really small? Is that? I think it might be. It might be too small. 10 mil. I've got dimensions up here. External dimensions. Might be a bit too restrictive. External depth. Here we go. Let's do this. Let's do it this way. Oh, 6 is going to be pushing it, I think. No, it might be just enough. 6.1. Let's do that. $7.6 mil. 5.1 mil. Let's see if I can get this displaying slightly better. I'll check chat again in a second. I've not looked at it in a while. Character width. Yeah, these are really narrow character width, so they're really small digits. Character height. It's also width is now. There we go. There's width. Nothing. 9.7 is the biggest. was looking at the entire display width before, wasn't I? What was that on these things? Character width is 8 at a diagonal angle. Yeah. Okay. Let's do that then. Okay. Narrow it down some more. That looks promising. Orange. Chat. Let's chat and chat. Right. I had an issue with the arrow, did you? No, damn. I've only used them once and I was happy with them. It was very fast. And it's really well packaged, stuff like that. I was actually very happy with, with at least my experience with them. But I've only used them once. So, it's not a true representation, I suppose. On back order. Oh, really? $8mm wide, 19mm high total. Digit height is 14.2. That's very similar size to what's already in the Datron. And they're the right colour. And they're on back order. In April next year. Oh, that's not much of a wait, is it? Oh, man. Well, that's annoying. A bit of white part otherwise. Oh dear. Damn, okay. So they got these ones, which are yellow. Is that the same? That's the 106. K, that's different. It's different versions. Look at this data sheet then. These are at least in stock. 0.3 inch digit height. 4 wide. No. No, it's way too small. 7 high. No, way too small. That's a shame. So it's this 56 or 106 series I think I need to look for. It's like 56 series. So you got red ones. So I think 105 means red, 106 means orange. What is those flat ones? $6 each. In a bag of 100. How many of these am I going to be fixing? That's the orange one which isn't there. So this one here. In red, they have in stock. They're cheaper. Check the dollar sheet. $8mm wide, yeah, 19 high on the mountings, 14mm high for the actual digits. These look really possible. Yeah, Tim, what you suggest is, I don't see why it wouldn't work, but because I can get PCBs, can't say it, because I can get PCBs made for free, it doesn't cost me money to get PCBs made. I don't mind making using these parts. I mean, these parts are pretty cheap actually. These, I don't mind paying this kind of money for it. It will do the job. If it does the job, then great. So this one here is looking like a goer. 5 to 20 units is $4.70 each. So I'd probably get 20. Actually, I might do more than that. I might get a bunch of them. So if I've got, say, 30 of these, that would be enough to do, say, 10 digits per unit. So 8 digits per unit, wouldn't it? So 24 would be enough to do 3. I've got 32, it's enough to do 4 repairs. And then it gets down to the next price point as well. So then I'd be, only paying like $30 per pack. So it's doable. I think I can live with that cost. So if I were to get, say 20, what was it, say 8, 16, 24 would be enough to do 3. They'd be enough to do 3 repairs if I got 25 units with 1 spare. Is it possible to transmit RF with a functional signal generator? Yes, kind of. Probably unmodulated, if you can get high enough frequency. RF is just high frequency oscillation, I forget. No idea, sorry. Don't know about any OCR stuff to do conversions. No idea. Right, so I'll add it on the basket. In case you don't find anything else. So these are the lower profile ones. I didn't double check the height, did I? Did I? I better make sure I definitely got the right. Yeah, 3.75 total height. So I've got, was it 8.6 total height? So I've got 1.6mm PCB plus a little bit, call it 2mm, right? So that gives me 5.75mm. So it's still a couple of mil away from the display. So I've got heaps there, which gives me enough room there to put some double-sided foam in behind the back of it. 1mm double-sided foam. 2mm even if I wanted to touch the display. Done. Yeah, sweet. That'd work. That'd work. So that's the way to go there. Yes. Okay, what other ones we got in here? So I'm looking for the 56 series, wasn't I? So that's Kimbright. That's red. Double digit red. 2 digits are, yeah. What's that was? That was 105 red. $4.70, so that'd be $9.40. So double digits are cheaper. Double digits are cheaper. If they're cheaper, why wouldn't you do it? Do they have them in stock? Isn't that orange one here? Oh, 400. No. I really want an orange one. I prefer orange to try and keep it original. So that's everything there. Here we go here. So these are cheaper if I get them in these, and I've got 10 in stock. I need 8 digits, so that's 4 for each unit. So if I've got 8, that's enough to do 2 repairs. If I just get all of them, let's check the specs just to be sure. Yeah, I'll be making custom boards with PCBWay. That's what I'll do because of their sponsorship. So I'll just say, hey, I want to make some PCBs, and they say sure. I'll just upload the files and they just approve them. I don't have to pay for it. So that's how it works, which is great. It's great for me. It means I can do these little projects and get stuff done much cheaper. Now, if I was paying for these PCBs, it would cost me a lot more money. Okay, so look at this. 25 wide, 19 high. So it's basically the same. Digit height 14.2. Yeah. Digit width, does it show that, or does it show overall digit width? Yeah, there you go. 8's the same. Yeah, digit size are exactly the same. Common cathode. I don't remember. I never remember these bloody things. Is that cathode? Common cathode? I never remember these. I never remember that stuff. Yeah, CC, common cathode. What did the unit want? Come on, you guys can tell me. I never work this bloody stuff out. Common cathode. It's basic, but I always forget it. It never sticks in my head. Let's find that diagram down here somewhere. Come on, where is it? Was it one of the last pages, not one of the first ones? I don't remember. Here it is. So is that common cathode? I don't bloody remember. So the digits are being pulled to 5 volts, and the segments are being pulled to negative currently. Of course, I could change it anyway. I could always swap that around, but why would you? I'd make this pull into 0 volts instead, or something. So I've got 5 volts here. It's got some dropper resistors in there as well, actually. So I have to work that out as well for what I can actually drive them at. So that'd be common cathode, wouldn't it? Come on, guys, tell me. Common anode. Oh, fucking hell. Do they have plus minus overflow segment? I didn't see it there. No, I didn't seem to be listed there. But I only have to worry about displaying a negative, because if it's not a negative, therefore it's a positive. So you don't need it to say positive. And if I use one digit just to display a line as a negative, that'd be fine. Yeah. So common anode. Right, so the display I'm looking at is a common cathode display, not common anode display. But this is changeable. If you think about it, I'll go to the correct window again. These are inverters, right? That's inverters. You've got a positive coming in, it switches the negative to give a negative output. If I dump all these transistors and go straight from the gates of these, that will then drive directly with a positive instead of a negative. And then if I come up here and do the same with these are also inverting. So it's obviously doing a negative out to get a positive. Do the same on these, straight from these gates, assuming they can drive the current, of course. Then that'll reverse it and make it the other way around. What do you reckon? One of this thing can drive the current. That's the only thing, is they can drive current or not. Because I'll be looking at I'll probably have to drive them quite hard to keep them nice and bright. So I think they're rated at 20 milliamps, weren't they? I'd probably do something like 15, so I'll drive them fairly hard. Doesn't say there. Yeah, full current, 20 milliamps. So you sort of want 2.2 volts, most likely, to drive it. Absolute maximum is 30 milliamps, absolute max, so you want to keep away from that. So I may even drive them 20 milliamps. I wonder if the actual ICs can source that much. Source and sink those currents, otherwise I will still have to use transistors. But it might just be a case of repopulating it and swapping from NPN to PNP and reverse things. It might be possible. What do you guys reckon? Yes, true, because I'm driving a whole segment, a whole digit, so yes, I have to allow for the sum of the current. You're right, I will have to allow for that. Can't swatch polarity, that's a point. Have they got any of these displays as common anode? Because if I can get a common anode version, then that might solve the problem anyway. If I can find where the page is. There's common anode over here, you can't quite see it. Or get in the right window and make it smaller. Common anode. So I do have, that's a common cathode. Double one's common cathode. Another common cathode. Ah, that's annoying. So the dual displays are common cathode only, but the individual displays have common anodes. So I might have to live with a greater cost and have the common anode version in order to simplify the conversion. My streaming seems to be behaving now. I've got a green light on here. Well, that means I'm going to put the speed up now. Stream health, let's check that out. Fine. I've had a warning 10 minutes ago, apparently. Okay. Maybe not. Maybe I'll leave it where it is then. Okay. Right, so what I'm thinking I should do is stick to a single digit then, because then I can get common anode, and all I've really got to do then is convert that minus 175 volts up to 0 volts or something like that, in order to also get the correct voltage I need of 3 of the resistors as well for the current draw I want to shove it through it. Let's look at the diagram again. So we've got, so if I don't reverse all those and keep those as they are, we've got resistors here which are 2K, 2K7 on each segment. That one's got 2K2 on that one, interestingly. But 2K7, this one's got 1.8K. So I have to watch out for that because it will give different brightnesses. Rear and ppm. Okay, I wonder what I've got different resistors in here. Okay, so we've got those, and on the digits we've also got resistors which are 1K, it's like, through all of them. Yeah, 1K across all the digits as well. So if you say 3.5k ish with 5 volts, I can never do this stuff. Let's work this out. Calculator. Resistor calculator. Pull one up. So I'm going to beat this here, I'm sure. LED resistor calculator. It's just easier to do it. LED resistor calculator. I use these things often. Well, often-ish. Sometimes. I use them sometimes. That's what I'm looking for. Okay. So 5 volts. Let's say you got 5 volts. You want about, what I say, about 2.2 volts or so, roughly. Full current, we want 20 milliamps. So 140 ohms. It's a bit different. What if I leave the supply voltage alone? What do we get if we leave the supply voltage at that massive voltage? So we've got 180 volts. Forward voltage 2.2. Forward current 20. Oh great, scientific notation. Come on guys, work this out for me. 8.89 plus E3. I hate scientific notation. Top one switching digits and bottom one is driving segments. Yes, that's what it looks like. Yes, Christian. No playing right for the past half an hour. Cool. Well, I've just seen some yellow flickering now in my streaming, so I'm going to leave the settings as they are. Okay, scientific notation. What the hell is this thing? I don't like use scientific notation. Plus 3 digits. Is that 800 or 900k? 900 ohm? What did you use wrong? Oh, I don't know. You've got 180 watts. 180 volts being dropped across a resistor. Yeah, voltage is probably going to be pretty high. Right, 15. So what's that? 1.1k. 1.1k resistor for that. Nearly 2k. Yeah. So if I ran these at 5 milliamps, I could use the original resistors. Yeah, well, that's the thing. It's a high voltage. You got 8.9k. Yeah, okay. Interesting. I hate scientific notation. It does my head in. I'm not a maths person. So is that 35k? Yeah, I think I should stick with. I think I should just like tie that rail to 0 volts. Have 5 volt supply going through with the. If I just do it that way, that should be an easy modification, I'd imagine. Because we've still got these resistors here, which are 1k. Yeah. Yeah. I'm also wondering if I have to swap it as bloody transistors as well, because these are high voltage transistors. I might have to swap them, but they might be okay. So all I've got to do is change this rail here. So instead of being minus 175 volts, it'd just be 0 volts. Just change it. There's a wire link here, look. How convenient. Link 1. I could change that. Take that link, make it 0 volts. Boom. Done. How convenient. OK1. Who is that? There it is right there. So that simplifies the modification as well. Turn it to 0 volts. And it takes away that high voltage straight away. Nice and easy. So then I have to obviously swap out these resistors here to suit. But that's not a big deal. That's not much effort at all. Or bridge the resistors even. Oh, I don't know, because it's going to be... Oh, it's got resistors here for the gate, so... It's got series capacitors, which is interesting. Because that's stop noise. Switching noise. So I'd be inclined to replace these ones and bridge these ones. Why is there two rails here? There's a rail here as well. Hold on, what's this going on here? What's that doing? So you have a voltage divider going on here. That's 75 volt diode there, so that's dropping 70 volts there. I'm going to have to watch out for that too. So it's not actually 5 volts here. Well, it's going between 5 and, well, 5-ish. And this, what's that bloody resistor value on those things? It was in the BOM, we did see it listed in there. So obviously that's a voltage divider system, so it's actually pulling the voltage down as well. That makes things a little bit more interesting, but not a particularly big deal. And it's coming down to these two, through those ones. Should have noticed that sooner, shouldn't I? So we've got this voltage divider going on. Okay, curious. No, I use Apple iPhone. I don't have an Android phone. Electro Droid or Electro Dock. Electro Dock, eh? So look at this. Just look this up now before I forget all about it. So yeah, because of these voltage dividers in here, that's going to be interesting as well. I might actually have to measure that and see what's going on, rather than trying to work it out. There's an AN3, is it AN4, AN3? Yeah, AN4 and AN3, those little resistor ladders. They're doing those pull downs and pull ups. Right. Electro Dock, did you say it was? If I type it right, it's also helpful. $6.99. Resistor color codes. Color by value, SMD resistor codes and data color codes. Ohm's law, reactance, resonance, filters, voltage divider. It's actually quite a handy little app, looks of it. Lots of stuff which I wouldn't use, but it's also the sort of stuff which would be handy. So I have to use my internet all the time, trying to find it. Rating's not bad, 4.5 out of 5. We've only 2 ratings though. Okay, I'm going to get this. It's all your fault if it's wrong. If it's no good, I don't know. Purchased. Okay. Yeah, so it's going to be floating voltages on both sides to make sure that it's biased correctly, I suppose, biasing. So that's the pull up side, 1K through there. So what's this AN4? Let's measure what AN4 is. Hey, switched, cool. Did that properly. So we got, there's a few of these. There's one here on the front, there's 2 more on the back. Which one's which? I should actually figure that out, shouldn't I, before I know what I'm doing. Let's go back up. Once I find out where they are. Okay, AN4 is the right hand one. AN3 is the left hand one. Common is behind the socket, of course it is. Should be able to just get onto one of those legs like that, and any one shouldn't really matter. 330k on that pen. Let's try another one. 330, so it should probably be 330 then. 330, that's what that one's doing. So AN4 is a 330. AN3 was the other one. That should be the same then. If I can get in here. Yep, 330. Another pen, just to be absolutely sure. I'll get on one. Try and get that little gap. Yeah, 330. So those dividers are 330k. Should really start making a note about this, shouldn't I? Got another warning about my data rate. Get my notepad out. So AN3 and 4, AN3 and AN4 are both 330k. So that's these two up here, the side I just measured. Okay. So I was dividing across the 5 volt with a 1k. Is that? Yeah, 1k. So it's 1k pull up, 330 pull down. Who wants to work that out? With 175 volt pull down. Yeah, okay. I'm going to draw a little picture of this. So you've got 5 volts through 1k. Yeah, it's this. First, some of my own notes, which is then going to another resistor here, which is 330k. I might work all this out later on. That goes to minus 175 volts. And that's what goes out to the digit. Right, notes. So that's the first section, and then the bottom section. Although, is it 175? Because here's got this going on. Because you've got 180 coming here. Well, it calls it minus 180. It's actually, well, I suppose, depends on what the 5 volt rail is tied to. That's 75 volt there. So I think actually it's a, well, 75 volts in this would be minus 70 volts, wouldn't it? There's only minus 70 volts there. Let's power it up, find out. Let's move this that way. I'm pretty sure it's minus 70. That's what I expect to see there. I'm not sure what a common is, so I guess we'll find out. We'll try that one. And there. I'm getting 5 volts there. Nothing there. Is that 5 volt tied to? Shall I see a 5 volt there? 4.9 volts there. That's curious. Here's the jumper link, 4.6 volts. Relative to chassis ground. Okay. We've got tantalums over here. Let's look at a negative on a tantalum. Or perhaps one of these other devices. I don't know, there's a negative here somewhere. Let's try and open there. Let's plug this in. It shouldn't matter, I don't think, but let's do it anyway. Maybe a high voltage coming through there. $70 volts, there we go, minus 70 volts. Hopefully you can see that. I should record this too, shouldn't I? Seems to be diagnosing this thing. Can you see what I'm doing? Barely. There's my remote one. Okay. So I'm looking at reverse engineering this now and just trying to figure out what I can do for the display. So what I'm looking at doing now is using individual 7-segment displays, making a circuit board up for that and replacing this whole thing with a 7-segment display array and losing a low voltage drive. So I'm just checking around and finding out what we've got going on here. So relative to chassis ground, we've got the junction of the Zener diode and that R41. We're getting minus 70 volts there. So that is one of the supply rails which goes via the various switching transistors over here to drive each digit. So that's a digit drive, and also a segment drive as well. So it's referenced to minus 70 volts on one side. Okay, so that was right at least, minus 70 volts. Yeah, I'm getting some better, kind of. I'm getting some better rates. I say it gets better, then I'll see it drop down again. So, yeah. Well, I'm looking at the main supply rail there. So I was looking at the main rail. So that point here is what I was looking right there. So that's at 70 volts or minus 70 volts. So that's a reference for these pull down side of these voltage dividers. So that's not minus 175. That is minus 70 volts. Okay, so that will mean later on I'll sit down and work out this stuff for the actual voltages. I could measure it, but as I say, it's multiplex, so I won't be able to see a true voltage because I have to use a scope to measure those. So I was calculating out based on the resistor network on here. So 1K with 330K between 5 volts and minus 75 will cost 175 volts. What's the resistor divider costs 175 volts? Well, sorry, 75 volts. Does it have any? I think it had voltage divider in here, didn't it? Yes, it did. So, how do we do this? Value of R1, and we'll call it 1000. 1000, okay. Use a new app. R2 is going to be. That's not right. Hold on, I tapped on the wrong thing. 1K. Here we go. 1K. Let's do it that way. I tapped on the wrong thing. That's so silly. R2 is going to be 330K. Okay. No loading. Voltage. I'm going to say 75 volts across it. So have I got that the correct way around? No, I've got it the wrong way around. Because the network works backwards. It's oh, is it? I don't know. Reference to ground. It's a 0.23 volt drop off the main rail, so it's 0.23 volts down from the top rail. That doesn't seem like much, does it? New subscriber. Hey, you've changed your name. Okay, cool. Yeah, so which way do I think about this thing? Because it is a pull down. It's saying it's 74.77 with a 75 volt supply. Obviously, that's going to be 4.77 volts. It just seems weird. I suppose it's 4.77 when it's on. When it's off, that'll be 70, won't it? Minus 70. So we're switching between minus 70 and 4.77. That's what we're doing. Okay. So if I were to remove R41, then it'd just be open collector, wouldn't it? It'd be nothing or 5 volts, and then I could potentially link that instead to 0 volts. Now it's then switch between 5 volts, 0 volts. That works, doesn't it? So if I get R41 and link that instead to 0 volt rail instead of the minus 180 volt, that will also do the same thing for the digit display. So I should find out what these are as well. So AN2, I should measure that one, and these have got 2.7K resistors across there. So AN, I might have noticed down now, AN2. Let's find out what that is. I hope you like the automatic switching. I need to build some more of this. I was going to make a controller for this thing, so I could tell it what camera to switch to, you know, which view. I never got around to doing that. So AN2 is the front one here. That's also 330K. I could, of course, read it off the front of the actual unit too, couldn't I? I can, but I like to measure things. So that's 330K as well. So these are being pulled down more because they're only 2.7k across them. Let's see what the app says. So I've got 2.7k. That's not much difference. That's 74.39. So it's 4.39. That's the positive side. Negative side is that one. It's the other way around. Hold on. So you've got minus 175 that side. It's different. So let's note this out again. So the so which side is effectively a pull-up then? The minus 70 volt will be effectively a pull-up because the other side's lower. Yes. So that would be minus 70 at the top side, and the other side you're getting pulled down. So it's minus 70 through to minus 180 with the resistors. So that's 110 volt supply effectively, isn't it? Yes. 110 volt supply with this, which make sure I've got this the right way round. That's on the negative side. This is the other way round. So it's 330 on the pull-up side. Yes, yes, 330 on the pull-up side, and 2.7k on the pull-down side. So that means it's basically, it says 892 millivolts for the negative side on that divider. So 900 millivolts above the lowest rail. So call it the last rail. Interesting. Wonder why they bothered doing that actually, in a way. So yeah. So that's going to be minus 180. Okay. Get it right around 330k here and 2.7k there. Right. So the voltage dividers aren't actually doing that much at all anyway. They're really negligible. It's obviously there just to reduce current through the system. That's all really. When switching between this side and that side, that is dividing the voltage slightly. It's not doing a lot. It's not having a great effect. It's mostly there as a current limiting system. That's what I reckon. Excellent. Okay, so not a big deal to change this. All I've really got to do is change this point here to be a negative. And I might have to take this resistor array out. Or do I just leave it floating? If I leave it floating, change that link there to be negative. Yeah, cut that, break that link, make that negative there. If I pull that, we've got 660 odd K between segments on each one, so there's not going to be any leakage voltage really to worry about as far as lighting segments up. Be negligible, so it shouldn't matter about any backflow through the resistors. So got a massive cap here already. It doesn't matter. That's fine. I can stay as it is. So yeah, make that 0 volts there. That'll make sure these all pull down to 0. Change these resistors to be the right ones, and these are 1k. I'll probably have to maybe short these out as well. I'll have to look at that. Maybe link all those across instead, and leave that floating. Take that off. pull the R41 out, take that out, and that should work. Oh, you're watching on your phone, are you, Helmet? Oh, it's midday already. Wow. I'm actually amazed that my connection's got better as the days go on, but normally it's the other way around. Okay, so we have to change my notes here. Pull R41. Pull R41. Change link. Change link. What's it called? OK1. And that takes away all the high voltage stuff. And then we'll be driving with 5 volts. And then I need to, I don't know, which one should I change? Which one's be easier to do? So we've got 22 up to something 29, is it? Over here. And then we've got these ones, 30s, R18, all the numbers all over the place. R30s and stuff, so look, trying to figure out where they are. So this was just a collection here and here. Might need to do those as well. 18, 19, I have to look at those. Yeah, 19, 18, 19, 20 also part of the digits as well. So all the 30s. Yeah, all the 30s, 18, 19, 20. So that's this bank here, and these are all the digits. So I could replace all those with wire links. Take all those out, wire link all those, and then the other ones, which is 22, 23, 24, 25, 26, 27, 29, oh, 28 as well, there we go. So all those ones I will change to be a suitable value to suit the drivers. Would that be right? That's the segment drivers, and that way the digit drivers are driven hard. Yeah, that way the segments don't affect the digits. Digits will be tied. That's right, eh? Yeah, so the digits will be tied to the main rail, and the segments, so these are digits. So digits will be driven hard. No. Yeah, so 5 volts to the digit common. Doesn't go through a resistor, so it won't drop, so each digit should be the same brightness level. And then the segment control for each digit as it scrolls through. So yeah, that's fine. That's what I need to change. That makes sense to me at least. So jumper, I'll call it short. 18 through to well, I'll call it 18, 20, and 31. Oh, sorry, 30 through 37. Let's make sure I got that right. And so we've got 36. So I've got 30. Oh, I hate these numberings. Can't really see them very well. So then we've got 30, 32, 36, 35, 31, 37, 30, is that 33? So make sure I've definitely got the right ones. So we've got 30, 31, 32. Where's 33 gone? 36. Well, I'm losing track again. 30. 31. There's 33 down there. There we go, 33. 34, 35, 36, 37. Yep, just making sure I'm not going to do the wrong one somewhere. So that's that whole bank there, that's right. And our 30 to 37. Then change to 22 to 29, isn't it? Let's make sure. Twenty-two, 23, 24, 25, 26, 27, 28, 29, yep. And change our 22 to 29. It's quite nice to lay them out in this array here like this. Nice and simple. Sweet as. Okay, happy with that. That's my notes for how to convert the voltages. Simple. Right. What have we missing in the chat here? Yeah, the AN networks aren't really needed. Yeah, that's right. There would be no harm in me leaving them in there though. It's not. I could take them out, but there's no harm in leaving them in. I could either pull those networks out and leave that intact, or I can isolate just by taking that resistor out, and that will isolate the whole lot without much more effort. It also does have potential leakage between digits or segments. It's got the potential there with that. Those arrays still there. It's probably a bit small for you guys to see. So there will be potential backfeed through them, but when you've got 330k per resistor, so 660k, it ain't going to matter. It's not going to do anything, so I'm not worried about leaving those in. So, I mean, so this is just the simple modifications to pull that resistor there, and that kills the feed to all these. Having a Zener diode in here to the 5-volt rail doesn't matter. It won't do anything anyway. That can stay in place, and that means I've only got to lift one resistor and take that voltage off the whole lot in one go. Yep. Yeah. Okay. Yeah. We're depending on the chip driving it. Yeah. Well, I'm looking this chip up. MC14515. Let's look this up, shall we? Let's pull this back down here. MC14515. Mr. 1. There we go. Come on, give me one for the data sheet. Not some of these fake bloody data sheets. 4 or 16 line decoder. There you go. That's what that device is. So it's a latch decoder. So maximum drive current is 10 milliamps, so yeah, definitely can't bypass the transistors. Yeah. So it's got 16 lines. It's not using all 16 now, is it? It's only... Is it doing 11? 12? So it's got 4 spare lines. Oh, sorry, 3 spare lines. So that's that part. It's been driven by these NOR gates and directly from the CPU. What's this thing doing? MC6810A. What the hell's that? Let's find out. Let's just save this data sheet. I like to have data sheets, anything I look at, I always like to have a data sheet for it. So C6801A. Trying to find a site which isn't one of these spammy sites. MCU, MPU, apparently. 8-bit single chip microcontroller. It's probably got a mask on it then. See if I can find the non-spammy data sheet. Here's a spammy data sheet. So this is what it's using. So it's obviously that's what's doing the conversion and that side of things. Yeah, I'm going to go into the detail of this thing. This thing looks a bit more complicated than I want to go anywhere near. Shouldn't have to go near it anyway. But okay, that's that. We already looked at that thing up anyway. So we're pretty much familiar with how this works anyway. I think we're good there. What's that device there? One for 520. That's what it's like anyway. Could be 1 for 320. Dual up counter. Does that make sense? Pin assignments. It's got Q0 to Q3. It does have that listed on here. Kind of. I was trying to check these out. Q1 is Q0B. So pin 11, Q12, Q1, yeah, 13, Q4, yeah, there we go, yeah. This looks like the right part. So this thing here. This is like it's the device it's using. I could also look at the circuit board, but you know, that's the pin out for it. I'll save that diagram as well. Right. So how's it actually working then? That must be doing accounting for the ROM. Is it? No? I don't know what it's doing. Can't bother reading the description again. I'll say that data sheet anyway. Done. So I need to buy some LED displays. Let's get back to that. I got kind of sidetracked from that, didn't I? Which LED am I going to buy? Because I need something which is going to fit. So the dual ones are nice, but it's not. It's common cathode. So it would be nice to get the common anode version of these because they'd be cheaper, but not an option, which is a shame. I'm tempted to get some anyway. If I'm getting 10 of those, it's $80 worth of yeah, $80 worth of parts. Yeah. Yeah. I'm just tempted to get some, so I've got some. In case I change my mind about how to do it. I need 5 to do 1 unit. Right, 5 is enough to do 1 unit. If I do 10, it's enough for 2 units. I'll get 5. Okay. So this was this the right one for this unit I was looking at? That's the other one. I'll save that data sheet as well. Oh, we're done here. Okay. I'll check the chat again in a minute. So I've got the displays I want, hopefully. PCBs I can get made. I have to obviously model all that up. So this looks like it's fairly straightforward. Obviously then I've still got to do the enunciators and figure out exactly how I'm going to lay that part up. So 25 displays is enough to do 3 repairs with that's 25 the single ones. These are common anode, that's correct. Same size as those, that's fine. So that all works. I should buy those shortly. Back to the chat. Okay. Yeah. Yeah, 6801, yeah. Yeah, that's how I'm doing it. Yes, that's right. I could actually do my own inverting on the PCB, having some little surface mount transistors on each of those lines. That would have been potentially a simpler way of doing it. Yes, if I did have to do that way. But yeah, if I swapped out all the factory transistors on that board, I could then invert those instead. But well, RS gives me free shipping. With Arrow, I'm going to pay shipping, so that's the only problem. And even if Arrow were cheaper, it'd probably end up costing me more. So, why don't you post a link? Okay, links must be blocked. Hey Dave. Okay, thanks for dropping by. Oh yeah, a bunch of those things here. All right. Okay, so that's going to be good progress. I'm comfortable where I'm at, so I'm pretty happy with that. Actually, it's been a pretty productive morning, I have to say. So I was hoping to get the thing working, but this is also very interesting, and this would be a great little project to do video on as well. I asked for purchase more than $50 worth. Okay, maybe I'll look at that as well before I hit the purchase link on this. I'll just see what other options I've got as far as other manufacturers or other providers. Because if I can get, 2-digit ones for less money, it might be better. Or they might even have 4-segment ones. I don't know. Well, 4-digit displays. They might have those too. I don't know. Doesn't really matter much. All they've done is bank them all up, haven't they? But if I can get orange ones, what did I have here? Those are red, weren't they? Yeah, those are red displays. So if I can get orange ones in the right footprint and stuff, I'll do that. I'll do a bit more hunting, but at least I know I can get these. These will work, and that gives me both options. And I have to keep my options open. I may never even end up using the common cathode ones. May never use them, but I like to have the option. Yeah, it's been quite nice actually. That's why I like doing these live streams when I do get the chance to do them. Is that I have this interaction with you guys, and the discussions I have with you lot broadens my options quite a bit, I suppose. So I'll have an idea in my head, and I think, oh, I'll think of that. Then you guys will suggest something, which may work out better. Like you said, the LED displays, because I was going towards TFT and having the issues with the mating them all up and stuff like that. So yes, LEDs in this case will work better. I'll have to do some little tweaks for the annunciators, but that's not a big deal. Few 2-digit ones for $20 each. Okay, I have to go and have a look. What I will do is I'm going to make you a moderator, and that means you can then post links. Okay, so you can chuck a link under there straight to it. Yeah, so as I was saying, so having these constant two-way discussions is really helpful, because it gives me other alternatives as well, and I'm sort of leaning on the knowledge that you guys have had as well, your own experience as well, which is also very helpful. So hey, there we go, cool. Just checking that out now. Alright. Red, orange, common anode. Hey, they got some. Heaps of stock. Let me just check these ones out. Hold on. Maximum forward current 25 milliamps, that's fine. I'll be pushing them too hard anyway. I will be driving them fairly hard, but not all the way to the max. Dimensions, where's dimensions? Width 12.8 by 19.86, so yeah, it looks like the same size. Oh, that's through hole, that one. Oh, I'm looking at, it's not the right one I want. Hold on. I want surface mount. Nope, I clicked on something. So I've opened up the wrong browser window, so it's just, yeah, I need surface mount though. SMD, here we go. Where's the mounting options in this? Common anode, we'll click on that. And SMD, that narrows it down a bit more as well. Okay, supply that and see what comes up. These got the wrong pictures on them. They probably have. Red, green, and yellow. I was trying to look at these, open these up. Put this up here. There you go. So we got that, looks like completely wrong picture. That does not look like an LED display, does it? Or is it a matrix? I can't see, actually. I think that's what we want, not that one. Here we go, surface mount. Dimensions, where dimensions? Height 3.75, okay, so that'll fit. $2.31. Okay, let's double check the spec here. Common anode, yep. data sheet. So it looks like it's the same ones basically, doesn't it? 7.6 mil high. No, that's not right, is it? 4 mil. No, these are smaller. Ah, that's the wrong one. 03. I want a 5.6. No, 5.6 is the one I want. This one here. $7. So, yeah, not much in it. 17 high for that. Yeah, okay, that's yeah, there you go, 12.2, 8.1. Yep, so that's the right digit size. So I could get yellow ones. So now I've got a choice of yellow or red. Yellow 2 digit. Okay, so we'll grab that data sheet in a minute. So this one here, $7 each. So if I get 10 of those, it's $70 worth. Yeah. And shipping maybe. Country of origin China, of course. Yeah, okay. So I've got two options here. I have to look at the shipping from this one. So that's $70 at least US. This would be US money. Pretty sure it is. Yeah, US dollars. Yeah. So for me, it's, I'll say about 50% more, so it's about $12 a module. Yeah. I think the individual ones are cheaper in that case. Yeah. I think yellow would be better. $6 by 10. I didn't look at that actually, the quantity thing. Oh yeah, you're right. Yeah. If I get 25, do only 25 of them, then they get down a bit more. Yeah, okay. But I think yellow behind the orange will come out. I think that'll come out alright. Won't be too far off original. Yeah, I'm inclined to go the yellow. If I can get yellow. It might take longer though to get here, it's anything. Because the RS one will probably be quicker. Trade-offs. Okay, at least I've got options though. That's good. Well, the amount of work to assemble those modules versus the individual modules is about the same. So, because they've got the same pinouts, it just got two stacked side by side in the same package. But the pinouts themselves will be the same. I think. Maybe they're not actually. Let's look at that. They might have less pins. Because obviously the pins are tied together internally, so they do have less pins. But obviously you've got a separate digit selection. I do have less connections to do. Another benefit, isn't it? Simpler to assemble it. I'm leaning towards these ones, actually. It might take a bit longer to get them, but I'm leaning towards these. I think a bit longer to get them, a bit more expensive, but it's the colour I want. I prefer orange, but yellow is probably going to be close enough. And assembly would be simpler. I think I'm going to go with these ones. That is a good find. Well done. Yeah, Arrow shipping is fast. I mean, when I got stuff from Arrow before, it took a week to arrive. But that is about a year ago. And the shipping delays we're getting now are much greater than that. Stuff coming to the country just it's taken ages. Yeah, so that's what we're looking at now. So, okay, I think I've got a direction to go in. We've got two options as far as displays to use. Double digits from Arrow or the single digits from RS. I haven't looked at Element 14 yet. If you do a certain order size, I think it's $50 on Element 14 as well. Then you get free shipping on that one as well. So Element 14 is also very fast. So at least to me, it's fast for me. You know, a week is fast for me. All right. All that will still arrive before the PCBs arrive. That's the other thing. PCBs will take probably 2 weeks. Probably what, 3-4 days to get them made, and then a week and a half to arrive. They usually come through DHL, so they're usually a little bit better. Let's catch up with it again. Is that one too small? Let's have a look. So that's orange. 0.28 inch digit size, that's slightly smaller. Let's pull the data sheet up for that one. Yeah, the digits are only 4.6 millimeters wide, so they're almost half as wide. 7 millimeters high, so yeah, they're half the size. So no, I want to try and keep them as close as I can to the original digit sizes. The original digits are really easy to read; they're quite good. So I don't want to go away from that if I can avoid it. So the 14 millimeter high digits are very close. It's basically the same as the original. I think they're about 15 high or something like that. Is that right? Did I measure that right? Am I remembering this all wrong? Do I have to start again? Digit height is 16 digits, 16 millimeters high, and the width of a digit is about 8. So the ones we're looking at are very similar size. They're just very slightly shorter, but about the same width. So I'm happy with that. The one other thing these have, I was looking at this display, they've got the, well, I don't think you can see it on here, even if I zoom in, probably not, but the digits have got, obviously the 7 segment digit, and then you've got a dot in the middle and a comma. Is that going to cause a problem? What's the dot in the middle for? The dot is the dot. What's the comma for? It has the dot in the middle of the display, right? So, is this going to cause an issue? Now I'm wondering about this. Because there's a comma and a dot. What's the comma used for? I don't remember seeing the commas used. Because the dot is the dot, it's fine, it's just the middle of the display instead of down the bottom. Right, that's alright. The dots are used as part of the text when you're doing text displays. Like error is using an R, and the dot is the curl of the R. Is this going to cause a problem? When I do a display test, there's no commas lit up. So it's not using the commas, it's only using the dots. What that will mean, I don't really have the means to show you, not easily right now. So if I go to the Datron, but maybe it'll show it on here in the manual. Actually, I'm going to show you on here. There we go. It's right there. That's big, so you can see it. Okay. So we've got the dot there instead of down here, and it's got the comma, just marked as L. So H is the dot, and L is the comma. I haven't seen that comma used, and when I just did the display test, it didn't light up. So H is the dot, H. So it looks like it isn't actually using that at all. Maybe it's used on a different model. Is that what this one is? Is it J? Or is it I? Is that an I? It could be an I actually. It says not used. So okay, I think we can ignore that comma then, so that's fine. But it will mean that when we display things like the word error, it's going to have a dot down the bottom here instead. Is that a big deal? Not really. We look a little funny. Yeah, small price to pay though, isn't it? Because it does display text on display a little bit, you know, in some aspects. In that particular case, it says error. I don't think there's anything else. Yeah, I don't think so. Check again. No, it's been scrolling past. I lost where I am now. That's the wrong size, is it? That's too small, yeah. Okay, that's too small. Right. Reaching 4.5 hours. It doesn't feel like 4.5 hours. Yeah, A to F for the normal digits. A, B, C, D, E, F, G is the bar, and H is the dot. Which I think is fairly normal. Pretty sure. Yeah, I mean, I think having a dot showing up at the bottom of the display, is it leading or trailing dot? That's the other thing I need to think about too. This is when it's displaying a dot, it's not displaying anything else unless it's an R. It doesn't use the rest of the segment, only uses the dot. So that won't matter which side it's on. Because it turns the rest of it off and then just displays the dot only unless it's the R. In which case it would be an R like that with a dot down one side or the other. Which side was it on? Where's the dot on here? Hold on, where's the dot? Oh, next problem. There's no dot on these. There's only the actual digit. There's no dots. Damn, it's not quite right. There, I was thinking we had something. That's too wrong. That's too small. That one. That's not the right one. That's the arrow ones. Go to here. The ones from RS have a dot on. Okay, so that goes back to RS again because they got a dot. Almost forgot about that. So the common anode individual digits from RS. Let's put his data sheet back up again for that. See, these ones have got a dot on. So I'm going to have to go with these ones. Oh, that's close. So if we get the 2-digit ones with the dots, we're good. Right, okay. Damn. That's a shame. Anyway, so the dots to the right hand side, so that's what I was trying to look for. Yeah, usually the dots on the right hand side, but sometimes they're at the left. I've seen it on the left hand side before. It's not as common though, but usually on the right. So I'm going to have to go with these. So when it does an R, it's going to be that. Oh, you can't see it. Here we go, this one. This screen here. So when it does an R, it's going to be that with a dot over here. Not a big deal. It's a small price to pay to have a working display, isn't it? Actually, what I could do, because it doesn't need to use the dots in every segment, only uses the dots in certain spots, I might be able to not hook those up. I don't know, they're over here. If I do, hold off. That's that digit there. So that's, I'm just looking at the digits now. So I've got, if I do that one as the first digit. 1, 2, 3, 4, 5. 3, 4 and 5 have the dots on. If I'm doing a voltage measurement, digit 4 has a dot in used. Is that right? Oh, is that right? 1? Come on. 1, 2, 3, 4. So 3, 4 and 6 have got the dots on. And in DC volts, number 5 is using the dot in that particular range. Then it goes to that one, then it goes to that one. Right. So one of these dots I don't actually have to hook up, which would be one less rogue decimal place showing up. So the one that's in position 6, if I don't wire those ones up, say 6 downwards, it won't show them up. Because it only uses the first ones anyway, so it only puts decimal places in, where's the first ones here? First one it will use is on the second digit. So I do the second, third, fourth and fifth digit, we'll put decimal places in. That works. So, okay. that will at least eliminate one of the rogue dots from showing up. As long as none of the displays which use them. I don't know. I might wire them up and figure out if I could always put a bit of tape over it, couldn't I? That'll cover it up. Right. Back to the comments. Well, the iOS component one, they had the dual display. That one? No. I've lost it again. Where are we? 56, that's the right display. Just the wrong polarity. I'll dash out for that one. So this dual display has the dots on it. So they are available, they are out there. It's just a shame this is the wrong type. You know, if it's common anode, not common cathode, problem solved. But then this is also using all these pins. It has individual pins still for each unit, so it's basically like having two single ones side by side. So in this case, there's no real benefit to using double anyway, apart from reduction in cost and buying the unit. That's the only benefit. So, okay. SMD solves some problems, so yes, it does narrow the options a little bit. SMD means I can have the back of the board dead flat, dead smooth, no solder joints on the back, no through-hole wires, nothing on the back of the board. It can be completely blank, no conductivity at all. And it being completely blank means I can put double-sided tape on and hold the display on with that, and it'll be dead smooth. It will sit nicely. Also means there's no possibility of shorting out against the main board on the back, on the original face. I will need to figure out how I wire that in as well, though. I have to figure out the interconnections between that circuit board and the connections on the back of the existing board. Because ideally what I'll do is then have through holes just for the interface between this replacement board and where the VFD currently is connected. So I can use exactly the same holes and use those as the feed. So I don't have to do any manual wiring, I can just go straight into those original holes. I should be able to do that. There's enough space because all that is above the display. So I think that should be fine. I don't think there's a problem there. Let's check that. Yeah, all the holes are on one side. There is something behind that VFD. I can see one thing there. Because the VFD is stood off on a bit of tape, but that's fine. I do actually have some clearance anyway, so it's alright. I've still got a bit of room to play with. Yeah, so back to what I was saying. So being surface mount means all your things on one side of the board. It's easy-ish to apply. I'd have to use a soldering iron, not hot air, because otherwise I might melt the plastic on the actual displays. Not a big deal. So the back of the board can be completely flat and clean. And the only thing I'd have to do is say the interconnect onto where the VFD is currently connected to go through those existing holes. And that shouldn't be too hard to model that up actually, it should be pretty easy. It looks like it's a 0.1 spacing, so standard spacing, nice and easy. There's lots of pins on that VFD. I also need to think about the LEDs for the annunciators as well, how I'm going to do that. I don't think I've got any surface mount LEDs actually. I will have to get some surface mount LEDs. And that's try and get ones which match the VFD. Well, the main display, be the same colour. I must forget that. But But yeah, that's why I want to do it. Because if I have through hole, then I'm going to have holes sticking out the back on solder joints, and it's going to be bumpy and not going to be smooth, and that may cause problems with mountings. And it takes up slightly more height as well. So I do have a bit of height to play with, but not much. I don't want to waste that on having holes, pins sticking out the back of the ball. So for stay with surface mount, from an assembly perspective, surface mount is going to be a little bit harder, but I think it will give the better result in the end. Where are we? Yeah, what I did is I was on my Datron behind me. Probably kind of, I don't know if I was in shot or not. I was going through the ranges on the voltage, so I was using the voltage ranges, and that's stepping the decimal place along. So the most it does is most it will display is 1999 is the biggest display it'll do on a range, if I remember rightly. So yeah, and that first digit is like a half digit. Does that affect anything? I hope not. But at least I know what the annunciators are going to be controlled by, so I can try and figure that out as well, because it does list what they are. Go to here again. So it does show them remote. I think it's remote or rear, I'm not sure which one it says. It might be remote. PPM, AC, that I can't see what the symbol is. I don't think it's ohms because ohms is over here. Negative V and B. So negative is using the V first digit. Well, it's saying segment D, which I think, let's make it out slightly. Where is that? Here we go. Segment D is bottom line, interestingly. So underscore. But I think they might be using that digit as a minus on the very first segment, because you've got plus here on digit E, which is that one. So the very first digit I might have to actually consider what I do there, because if it's using that E to create a positive, then I might need to do a custom LED for that first bit or ignore it. I'm not sure. I think about that. This is all a bit hard to read. I do actually have a physical manual here. Right here, actually. Let me see if I can read it a bit better from here. I'll tell you what it says then, once I find it. This is for the 1061, so it's not exactly the same, but it's the same display and the same driver. That will pass exactly the same. Of course, when you start from the back, it's at the front. When you start at the front, it's at the back. I don't know. So it works. Here we go. I can see it from the back of the paper. Right. So I'll try and get this on camera. I don't know if you'll be able to see it or not. Probably won't focus on it, but we'll try. So that is what we've got on the actual physical manual. So ohms and cal K and M. Yeah, amps, milliamps, million percent, and micro and D. So physical manual, always handy to have. That's why I always get them. So yeah, at least now I can see what the symbols are in here. Although these look like they might be slightly different. They could be different. So that says remote in ppm, that's right. That is that symbol, whatever that is. I don't think it's ohms. It looks like an ohm symbol, but why do they have two ohm signals? Don't know. KM, let's check it. I was trying to compare these. Up to here is the same. So that says amps there. That's amps. Percent, yeah. So micro and D. So micro, yeah. I suppose it could be micro. Is that a D? I suppose it could be. So I think they are the same. So that's good. Yeah, I'm very fussy, eh? I'm very fussy. Yeah. Plus, minus, and separate LEDs. Yes. That's what it looks like, doesn't it? So I've got a minus symbol here. Or is that an underscore? I think it's a minus. And although that digit is the underscore digit. Minus is only ever the very first digit. I don't remember seeing it display a plus though. Does it display a plus? It's displaying minus. Oh, it does display plus, yes. So, yeah, it is indeed. I should be paying more attention to this myself, shouldn't I? I've got it on right now, so it's flicking between plus and minus right now. So it does have a plus digit as well. But to me, you don't need a plus digit because if it's not a minus, therefore it's a plus. Do you need it? I don't know. Having a minus digit, sure, but I think the plus isn't really necessary. But it does all this other stuff on here. It's got dB functions and spec values. Gives an error on that one. Forget that. Let's look at the display test again. Definitely no commas. Definitely no commas used. So I'm going to ignore that. A plus B. Turn hold of. Min max values. Yeah. So yes, I don't need to display a positive. I mean, a negative will be fine. So that particular one can not be used. I can just ignore that one and not fit that one in that digit. So on that very first digit there, I mean, is it displaying those as the first digit or the last digit? So all these enunciators, I mean, is it that segment is doing the positive? It's doing two functions at once. That's doing two functions at once. So there must just be a listing of what they're doing rather than the actual digit they're on. So they could be on any digit. It doesn't necessarily be that the negative is on the very first digit. It could be on the very last digit and it appears on the front. I'd have to look at that as well. Yeah, that's another little complexity to consider too. Should really make a note of which page is on. So 180 is a circuit diagram. Where is the description? That was right up top here somewhere. So 57. There we go. So that's what it's doing there. So yeah, that is first digit. Yep. So at least it does tell us here which digit it's using for each one. So that's good. So at least I know what I'm going to be dealing with here. That will display a 1 in here. So minus and 1 is all I've got to worry about. If I ignore the positive, I don't have to do that, which means I can just use the middle bar of that first digit for that one. And I wire that up that way. That'll be fine. That's simple then. I don't have to do anything special for that first digit. Yeah, that's fine. That's easy. Okay, that's sweet. Comment anode, yeah, that's right. That's right. So yeah, there's the ohm symbols here. There we go. You're right about that, Helmuth. So there you go. You got kilo ohm, mega ohm. That's why it's 2 ohm symbols. That's why that's done that way. So all I've really got to do is replicate this on a separate module using some discrete LEDs. Yeah, I'll have to use surface mount. I can't use through hole for that. I don't really want to use through hole anyway. I want to keep it flat. So I'll always replicate that layout. It doesn't have to be that layout. I can put any layout I wanted in, couldn't I? But if I remember that that one will be on, or this one will be on, I'll shift it over. Or could I simplify that? No, I think I have to keep it like that. I think I have to keep it that way. Yeah, I'm going to keep it that way. So that's fine. That explains why it's 2 ohm symbols. Yeah, it's got a separate symbol for positive and separate symbol for negative. It's not the same decimal. It's not the same digit. It's swapping digits. So the see here, make it a bit bigger. Get into our window, make it a bit bigger. So it is treating those as separate digits. So it's either putting a negative or positive. That's what it's doing. It's doing one or the other. So if I don't have a positive symbol, if I just use like the middle bar of I'm going to put an extra digit in there, right? So instead of being 8.5 digits, it's going to be, well, is it 8, 2, 4, 6, 7 digits. 2, 4. Hold on, am I getting this right? 8.5 digits. Yes, it is 8.5 digits there. So I'll put another digit in front of it, and I'll use those 2 bars there for the 1, like it's doing. And even if I have to link them together internally, I might have to do that. And then the middle bar for the minus, so it'd be -1, for example. Also means there won't be a space, it'll be like a sideways T. Is that an issue? I don't know, probably not. Or I do 3D print a custom thing here. But if I use a digit, it will then look exactly the same, at least on this piece. I don't have to use this in the digit though, so I could just use that leading digit there just to display the one only, and then have a separate annunciator to the left of that to show the negative. That's also an option. I could do whatever I wanted in that area. You know, I could just link them together and just wire it to that. So I'm not worried about that part of it. This will take a little work, you know, 3D printing and stuff, but it's not a big deal. I can make something for that. It's not that hard. The symbol for ohms could be a problem though, because the software I use for doing the 3D printing doesn't, or even the mu symbol, mu, it's called mu. Those symbols may not actually be created by the software. It doesn't like special characters. Same for this symbol here. I don't think I can do that symbol. I might have to say AC instead and put a standard U in here instead of a mu symbol. dB should be fine. The ohm symbol, yeah, I have to think about that as well. I don't think I can do an ohm symbol on it. Percent, I think it might be right. But yeah, it's great. I've got a really good direction to go in. I know exactly what I'm going to do. It's been a very productive day. It's really good. So didn't get what I wanted to do, which is electronic repair of that. But this is just as good, I think. Page 57, yes, 57. 180 and 57. I'm going to write this down. Okay. Page 57, page 57, and page 180. Don't know where to look for them. Referencing it. But easier, right? Don't know. MK's mu. I don't know. Yeah, so I think I'm good there. Yeah, it's micro, yeah. But it's called a mu symbol.
Want lunch?
Yes, please. I think about stopping anyway. Yeah, so that's good. I'm happy with that. It's been a very good morning. Very productive. And my phone keeps making noises. So I'm happy with that. That's good. So I know what I need to achieve. I found parts I can use. I know I can make circuit boards. I figured out how to rewire the display driver board so it will run display. That's good. I can 3D printing this, not a big deal, easy. I just have to figure out exactly how I'm going to lay this out and stuff like that. I think it's okay though, not a big deal. I'm going to have to get some surface mounted LEDs to run all this stuff. Don't tell my wife that. Yeah, helmet. That's also an option. 3D printing onto laminate. Inkjet. Laser printing onto laminate in order to get the symbols and then having the dividers. Yeah, that's also an option. What I found with 3D printing is that trying to do letters stuff like that, the definition isn't always good enough. So because I'm going to be making, if this is 3D printed, I'd have to do holes. So that might be fine too. But a diffuser behind it would be helpful. That's not a big deal. I can do some kind of diffuser, a bit of white sheet or something, a bit of paper even might work. Yeah, because definitely diffusing as well. Otherwise, it would be you'd be able to see these through the holes. So I need to think about how I build that. But I'm not too worried about that part. It's a little bit tricky, a little bit involved to get a good result, but doable. Again, not too worried about that. The hardest bit is going to be doing the electrical wiring of this stuff and figuring out which digits it's using exactly for each one. And making sure I get it wired up correctly. So all these have to be in parallel up. You know, each digit's going to be paralleled for the segments, and get all that correctly laid out on the PCB. All that figured out and laid out, and digit drivers. That's probably fairly easy. I probably will have to use double-sided board in order to get the layouts, but it won't have anything protruding through the back, and that's the important thing there. If I've got traces on the back there which are solder masked over, I don't care, that's fine, because I'm going to be sticking it on double-sided tape anyway to hold it on. 3D printing that's fine. Yeah, okay, that's good. I'm happy. That's a good stage to be at. Wasn't what I was expecting to be doing today, but still good. Indeed, Christian, indeed. Daughter 17, eh? Oh yeah. Stepdaughter is 16. The wife's daughter. Yeah, that's right. So negative images, that's right. So instead of being black on a clear, it'd be black around a clear. That's right. That's what I have to do on a transparency if I do it that way. I'll see how it go with the 3D printing. If the 3D printing one, I'll try 3D printing first, and put all the symbols on the front with the dividers inside. If it doesn't come out well, I can always put a laminate over the front of that and cut the face of those out, keeping the dividers in place, and then put laminate over the front. So I'll probably do 3D printing first as like the primary thing, and then look at a laminate as a fallback. That would be what I expect I'd probably look at doing. Cool. That's good. That's good. Happy with that. So right, I'm going to call it a day. Go have lunch, have another coffee. My throat's getting really dry now as well, talking. And I'm glad I did a live stream. It's been brilliant. I've been meaning to do one for a little while. I've been busy the past month, on weekends anyway. I haven't been able to do one. I've had, off and on, been busy on weekends, being away, that sort of stuff. So I'm doing my third job, I suppose. YouTube's kind of my second job, I suppose. So yeah, we'll call it a day. I'll wind this down. So thanks everyone for your help and your suggestions and leading me in directions and giving me your opinions. It's been very helpful, as always. And I'll catch you next one. I've got probably 2 weeks' time might be the next live stream I can do. Yeah, I think that's the next one I can possibly do is 2 weeks' time. So maybe I'll have the parts for that. Maybe. So we'll see how we go. Cheers. I'll be out in a second anyway. Just about done. Oh, it's going to fall apart.
That's why I need to hold it.
Got a wrap. So hopefully next time the internet behaves a bit better. I don't know. Yeah, it is a good project. I'm actually quite excited by it. I like to get my teeth stuck into little, slightly changing things. You know, it's good to have something challenging it once in a while rather than just to mundane replacing capacitors sort of thing. So cool. So hopefully in 2 weeks' time, if we're lucky, I might be able to finish this project off. We'll see how we go. If I've got all the parts I need, if we can do it then. Otherwise, it might be over Christmas. It's also possible because I've got 2 weeks off for Christmas, so that's also possible that I could do it in that time as well. Alright, I'll catch you later. Thanks for dropping by. And I'll catch you next one. Don't forget to give us a thumbs up as well. And subscribe if you're not already subscribed if you're watching and hang around. Catch you later. Bye.